and we'll say hello again. Okay, all right. Looks like we're on YouTube. Hello, everyone on YouTube. Hello again. And we'll do some benchmarking today. I'm totally unprepared today. Just too much going on one day. But we'll get through it, right? We always get somewhere. So maybe I'll present the goal first and roughly what's going on. So the thing is that the SurrealDB 2.0 got released yesterday or before yesterday. Let's see. SurrealDB.com. Let me share the screen. And wrong link. Oops. What is wrong? This one, please. Enter. Oh, geez. SurrealDB.com. There we go. So 2.0 of the database got finally released. It's not in beta anymore. It's a full release. So that's awesome. They have a great, half an hour long video showing through all the things that were introduced compared to version 1.5.5, and that's a lot. Whatever's mentioned in the video, it's just a little part of what actually got released. So yeah, it's absolutely awesome. So if we're gonna click learn more, we'll see that what happened, and looks like we have several videos about separate things that happened, including SurrealKV is in beta now. It's not something fully released yet. It's it's storage layer that's in beta right now. We're gonna see how it compares to something like RocksDB, and there's a lot here. I won't go through in details what happened, what not. We'll probably figure parts of it out as we're writing queries for both databases, the old and new version. And so the idea is that it will be nice to kind of compare the performance of old version and a new version of the database, because we have the older 1.5.5 and newer 2.0.1 by now. That was already one patch. And then we could also compare different storage engines. I won't be setting up any distributed store yet. I want to get my home lab set up again. Maybe instead of Nomad, I'll gotta try Kubernetes again and whatnot. At some point, probably on the live stream. And then maybe we're gonna test, how FoundationDB compares to TIKV and a few other ones. Today, the plan is to focus on RocksDB and SurrealKV. So I kind of started forming some kind of plan, all right? I'm gonna zoom it in a little bit. The idea is that we'll check the 1.5 or 1.5.4 in 3 different versions and 2.0 in 5 different versions, 5 different deployments, all right? So we'll have some setting up initially. So for the older version, we're gonna try it with RocksDB, then with RocksDB storage also, but on a RAM disk. That will mean that it's still logically using RocksDB, but the storage is as fast as possible. And then we're gonna also test the in-memory storage engine that's already built into SurrealDB, just to see the difference. Maybe, if somebody will want to go deep into data, this should already show the difference. What if there's no cost to storing data? What is the cost of storing data, and what is the cost of just the fact that it's RocksDB and not in memory, and fun things. And we're gonna do similar thing for 2.0, where we're gonna go through RocksDB, just normal on disk and in RAM for RocksDB, Then we're gonna go to SurrealKV on disk and on RAM disk, and then also for in-memory storage. So, we have 8 basically separate deployment. We'll have 8 separate deployment of the database that will be able to test the same queries as, throughout them all. I don't think we're gonna finish benchmarking the stream because 4 hours won't be probably enough to set it all up, but we'll start getting some results, right? We're gonna start developing a method for that. And then I don't want to limit it to just running on one computer. I figured I can run it on 4 computers. We'll have Homelander, which is the local PC that I'm streaming from right now. So we'll have, a high performance processor, plain enough of RAM, and, of an SSD. Then we're gonna have translucent. This is totally opposite. This is like a mini PC with power efficient Intel Celeron with some RAM and a slower SATA drive. So this should be significantly slower. Then we're gonna have a completely different kind of processor. Some embedded AMD Ryzen whatnot. Don't even know what that is. It's just built into a NAS server. So I think that's the slowest from all of those. Also should have enough RAM to run everything, so that shouldn't be a problem. And this is a different one because ultimately it stores data on hard drives, like not SSD, but it has an SSD cache layer because it's a ZFS system. So we'll see how that affects things too, right? Because we'll run in-memory and non-in-memory solutions there. So I'm curious how RocksDB would differ from SurrealKV in that case. And the fourth one, we'll just try to run it on laptop on the new Ultra 7 series of Intel CPUs. It's not anything powerful, but at the same time, it's not, not slow. We'll have a little bit faster RAM, so maybe in memory will be faster, who knows? And again, just a normal SSD. All right, so that's the plan. So we'll have basically, if all 8 SurrealDB deployments will be on the same computer, we'll run basically 32 instances of what do you call it? Of SurrealDB, at the same time, which is kind of fun. And how Mithridates? Mithridates says, hey, I think that bug you found a long time ago where you can set a field to some random name has been fixed. Yes, it's been fixed. I was trying it out and it wouldn't let me anymore. So I agree, it got fixed. So now that we have idea of what we're doing, let's figure out how we actually do it. So the only thing I prepared so far is I figured, you know what, I can make a probably Docker compose file that starts up all 8 instances. And the idea is to basically set up Portainer, where we can just start, restart, rebuild everything from scratch whenever we need to. And therefore, we have this Docker compose here. And let me just describe roughly what we're doing here. So we basic subservices. First one will be Surreal 1, as in 1.5.5, the RocksDB deployment, okay? And we just, set things up. Those parameters will be automatically provided by Portainer to some meaningful data. So we'll have, default user and password so that everything's just like you would do in your normal database. And this case, it's RocksDB and mapping to some kind of folder, right? Then we have the RAM version. So the RAM version is still starting it out as RocksDB, still saving data to this directory. The only thing is that instead of us pointing to a real directory on the host, we'll point it to the RAM disk, because apparently Docker comes with its own version of tempfs that's fully in memory. So this should take most of the overhead of actually accessing the hard drives or SSDs away. All right, it should just be all in RAM, but still running RocksDB, all the management, all the overhead that it adds. And then we're going to have the pure in-memory solution, where SurrealDB is just configured to run in memory, so it won't spin up any RocksDB. It will be just, I believe this will be the fastest solution, all right? So that's that idea. And then we have similarly for Surreal 2.0.1, we have a similar solution where we set everything up. The important thing is that I saw was missing from the documentation is that for SurrealDB 1.x, before you set your user and password, you also need to add this auth. What is it? Command argument. While for 2.0, you don't set that anymore. Okay. So that's that, and other is the same. RocksDB RAM. Then we got SurrealKV and SurrealKV RAM, and then the pure in-memory one. Okay, so this is the full 8 deployments, and they will just the port numbers will just differ slightly. So that's that, and I'm gonna actually try to log in to container management, and that's where we will need to solve some issues initially, all right? Because not everything is running as smoothly as I want to, as in some things are just not running yet. So let's just go here, container, let me just find the login data. Okay. And right now I deployed everything on Translucent. Translucent is the mini PC. So when I go here, we can see that there's one stack. No. Oh, I didn't deploy it here. Where did I deploy it? Oh, I deployed it on Java, sorry. The slowest one. I think the slowest. I can straight up remove the old tests, okay, because these are some tests that I was trying out. I will leave the streaming because that's the one that we usually we're doing live streaming. So I'm gonna leave that one. I'm gonna remove those few, and we have the Surreal benchmark. You can see that we have all those deployed here. Okay, like RocksDB RAM, it showed as normal deployed, it looks happy. Okay, and they're all available via different port numbers. So from that perspective, one is done. I am somewhat sure that it will actually work when it comes to those deployments. But the thing is that now we need to run the same thing on other containers, on other devices. So I think Translucent works, right? We were able to load it up, so we can go to stacks, create a new stack. We're gonna call it again SurrealDB benchmark. It doesn't matter too much, that particular name. And let's copy paste our Docker compose. Whole thing. Okay. This is running Linux, so I should be able to set things up relatively easily. So let's add environment variables. We need to specify the database user. In my case, I'll set all of them to the same thing, which will be root user. Then the password will be just some password. And now it's this part, basically host volume. So that's where I need to look in a separate tab. What did I have it set here to? Surreal benchmark. And I had it set to okay, I had it set to here. So I need to figure out where to actually set it so that it's gonna let me use it. Because this is not gonna be accessible to Docker, I believe. Do we have what directory in Ubuntu server can I mount my Docker volume? too, so that Docker has proper access to them, because that's something I'm not sure about. Var lib docker volumes. Okay. This directory is typically created when you install Docker, and its default location for Docker's volume storage. However, if you want to custom location there, optional or add-on software packages. Okay. Make sure to set the correct permission so the Docker daemon can access it. We'll just stick to that, all right? And we'll see if that works. Here's Java. So, wait, not Java. Translucent. There we go. So var lib docker volumes, and we're just gonna do /surreal. Okay? Or even better, benchmark. This way, it's not gonna get mixed up with anything else. And I think that'll be it to literally set it up. Let's see if that actually works. So we're gonna deploy the stack, and it's gonna take 30 years, and we'll know. Okay? Successfully deployed. Let's see. Oh, we got exit codes. All the ones that actually try to access hard drive. Okay. So there was a problem with the database. Failed to create RocksDB directory. Permission denied. Okay. So we know that this is not right. So let's go back and edit that variable. Wherever it went to. There we go. So what the heck do I set it to? Let's actually log in to that particular one. And we just connect to it, and we'll do some debugging. I'm not good with any, what would you call it? I'm not good with any DevOps. So we'll see. We'll struggle through it, right? So we're on the device. What the hell do I have here? I have Portainer, Docker Compose. I actually want to see that, because I want to see how is it different than what I have right now. 901, 900, and that. Okay. These are actually good for me to figure out. And that's var run docker socket, and we have share ops portainer data. So we know that this is somewhere where I can put stuff. Share. Oh. What? Okay, that exists. Okay, so we're gonna use share then. Okay, that was easy to figure out. I'll go for it. So let's just straight up copy it, okay? Come on. Container. No, we'll just do the, what do they call it? Surreal /benchmark. But I'm just gonna make sure that it exists. Share surreal. Oh, not ops. Share surreal benchmark. Surreal, right? Oh, wow. Oh, okay. Let's just save it and see what happens. Because, to be honest, I'm not 100% sure how all those, what do you call them? How the permissions work exactly in Linux. If I'm gonna create it as sudo, will it suddenly prevent something else to use it? Here, same thing. Okay, so let's do let's try that. It already exists. Really? Come on. And here we have benchmark. Okay. And we've got nothing here. So the thing got already created, but they have. Why is it like that? Okay. Stop the stack. Start a stack. Let's see if that changes something. If not, oh well. Let's refresh, and we already got the same error. Okay, I see. So let's ask AI. This is something that AI should be able to help us out easily because set the ownership directory to Docker user and group. Um, how can I check what is the user, Docker user and group to make sure? Okay, let's just do that. Docker at etc group. Okay, if it exists, it usually should look like that. So we're gonna do that and see what we're gonna get. Okay. It's literally this thing. It responded with this. How do I proceed to allow a specific directory? Why am I able to do the other stuff then? This is a weird part. But no user is currently added the group. This is common scenario. Yep. Choose a directory. Create a directory if it doesn't exist. Make directory P. What the hell is P? As in I can do slashes? So the ownership. Okay. So I do basically share Surreal benchmark. I have no idea if I'm even going a good direction. Because this will be ownership. Yep. Okay, and then it's set the permissions to allow the owner root full access to the group. Docker. Read and execute access. Okay. Let's just straight up do this, right? Sudo hmod. Okay. To ensure the new files directory are created with inherit group ownership, you can set the set GID bit. Sure, we're gonna do everything that chat says to do. Okay, great. It didn't complain about anything. So now it should be this. However, if Docker will file using sudo, you should add your user to the Docker group. I don't think I need to add my user, but we'll do that anyway, because it might be handy for the future. Okay. Oh, the user. Oh, yeah, sorry. There we go. And apply new membership without logging out. There we go. And this is, remember to restart Docker daemon after making these changes. Ooh. Sure. This one thinks a bit more. Olala is asking, do you work for SurrealDB? I do not. I just streamed SurrealDB recently. And they were thankful enough for streaming that they actually sent me a shirt. So that's very nice of SurrealDB. Okay, looks like it restarted. Let's see if we still see the portainer here, right? I'm gonna refresh. Okay, it loads up, so that's something. But doesn't mean that okay, now everything has exit code. Because it stopped. Wait, what the hell just happened? Stacks, SurrealDB benchmark. Everything stopped for failed to send shutdown signal to tasks. Okay, so I guess I just don't have them to automatically restart. So let's stop it and start again and hope for the best. And I'm hoping for the best that it all works. And let's refresh, and of course not. Why? Okay, time for the search. Portainer can't Portainer permissions denied directory volume. Ubuntu VM, blah blah blah. Volumes in a container. Then set PUBG of the container to user that has access to them. Oh. Read the files. I could not write to it. Local, making sure you have all required permissions to share. Oh geez, that's a whole tutorial. Okay, direct on container. Don't we already have it? Okay, we don't have that. How the hell do I add those? Sorry guys, I thought it's gonna go a little bit smoother. If I'm not gonna resolve it soon, we're gonna just go with running everything on one slow machine and locally. So let's do this. How do I make a container? Docker compose to how do I set on a container? Command first file system. Oh. I don't think I want to do that. What the heck? Let's change that question. Because I'm getting an area that I have no idea about. Let's just do it here. IDU, IDG. So it'll be environment and this. Replace with actual user ID. How do I check the actual user ID and JD? Oh, ID username. Just ID. 1000 and GID is 999. Groups and all that stuff. Interesting. There's one other option. I could just run the whole thing manually, right? The only thing is I'm not gonna get that nice dashboard, but Portainer should still see them, right? So let's try to make a Docker container quickly. I mean, Docker compose file for it. So I'm just gonna straight up copy that. Bam. And we're gonna do a new file. We're gonna paste it. The only thing here is I need to replace those with actual values. So this will be root user and oops, not that. This will be some password. Root user. Let me just try one other thing. Because we were suggested that mount option opt and custom directory in a root file system, Docker volumes. Let's try to do that then. I'm just gonna go mount, right? There should be nothing here. Make directory, Docker. Oh, so it's one of those. Huh. Docker. Everywhere, permissions denied. What the heck is this system? I guess I have permissions only to my personal space there. Oh well, but maybe it's actually possible. Sure, we've got here make directory Docker, right? So what was the current work directory? CW or okay, just like that. This will be my last try for the Portainer. Because in theory, the Portainer got started from my users, so should have access to that if it works that way. If not, we'll just do it manually and we'll do the rest of the stuff manually as well. So what we're gonna do here is change this up and we'll just do Docker and just call it a day like that. Update the stack. Refresh. And of course it's complaining. Of course. Yep. That says DevOps is the absolute worst. It truly is art of just Googling stuff until something finally works. I exaggerate a bit, but it's just so unpleasant. I agree. It's just painful. So, yeah, because you deal with permissions, and I mean, I never really focused on learning. Okay, how permissions work on Linux, how that works on Linux, all those million things, because it's literally a million things. So that's that. All right. So if that doesn't work, I was going to through this manual process, right? So we were going to just replace all those with that. All right. Just of that, and this should be good enough. Hopefully. I wonder if they're all kind of sharing partially the thing. Docker will be the data. Oh no. It's gonna be fine. So we've got all this configured. So let's save it. I'm just gonna save it here in Serial Benchmarks for now as a new folder. Translucent. I'm just gonna temporarily make some directories from which I can send the files around. So we're gonna make it docker-compose.yaml. I want YML. There we go. This should be saved. So what I'm gonna do is I'm gonna transfer it. Do I have croc? Yes. So we're gonna go here, translucent. And I'm just gonna do croc the Docker compose file. Okay. Yes. And let's just copy this. Okay, we've got the file. So let's actually move Docker compose to Docker slash Portainer. No, it's not Portainer. Docker slash, what is it? Surreal. Okay. What? Oh, I'm so silly. I renamed it. Surreal slash Docker compose YML. It's just so painful. Let's just leave it here, all right? We have this, so Docker compose app-d. Let's see if that's gonna work. Error from daemon conflict container, this and that is already in use. Oh, right. So we need to go to our Portainer stack on translucent and just straight up delete it all. So we stop it. And we'll delete it so that we don't have any of those containers. And now we can properly stand it up. And hopefully we can see containers here. Okay, there's a lot more containers here. So let's filter them down to Surreal. And we've got the same error, seriously? Oh my goodness. Okay, we're not running it on this device. This is ridiculous. Absolutely ridiculous. Yeah. Okay, so let's just fix the Homelander because I have some issues with Homelander right now. So let's just go back here and cat the Portainer Docker compose YAML in here because I want to copy it and compare it with what I have it set up on Homelander, which is this device. Okay. I'm clicking all the wrong things. You go away. You turn on, please. So we don't want that. This is the Docker compose on this device. All right. So I want to compare it here. 8,000 to 901. Okay. And I don't need those. What the heck? Where'd that come from? Yes, that is enough. Container. Yep. Image looks correct. Ports are correct now. Volumes. And that's the difference. Oh. I guess that's correct. I presume. What the heck? And we've got this one. Yeah. Okay. And environment. Sure. is container name all the way on the bottom? Okay, let's try that. This should be good enough. Hopefully this is gonna fix my problems with this thing. Ay, 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 ay. So we're going here, terminal, Docker compose down, and Docker compose up. Okay. So the thing is that I should be able to go. I mean, first of all, let's refresh here and see if anything just works suddenly. No, this one doesn't work because it needs to have this. Nope. Okay. So first of all, I'm just gonna go to localhost 9001. Does not work. Okay. I'm gonna go to the Docker Compose. Last started 53 seconds ago. Okay. That makes sense. And 9001 to 8000. So in theory, 9001 should work, right? So what do we have here? Because we have some stuff here. Blah, 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 blah. Can I make it larger for you guys? Yes, I can. I know this is not very exciting, but unfortunately, yeah. So it's listening for something on port 8000. And then we have HTTP server starting on 9000. So in theory, I should be able to go here to the port 9000. Oh, that worked. Now how on earth do I log in here? Like this. Oh, that logged in. And it registers itself as down. What the heck? Settings, general. I don't want Kubernetes on this thing. Yep, yep. Oops, not that. So nothing here, to be honest. You know, it's a fully running thing right now. If I'll go to wait, so this is an interface, right? And it shows itself as local. It says I'm running two stacks. This one is an old one, it didn't work. And itself. Okay, so that's something. Okay, okay, we're getting somewhere. So that means that I should be able to connect to it somehow. So if I'm gonna go to here, because this is on Java, that's the one that I'm using to connect to everything. 9000 environment address. The address of the container agent, host and port. Yeah, format is correct. Update, refresh. Does not work. And I'm not blocking any access either. Yeah, this is not great. Yeah, Um, hmm. Okay, to be honest, it's a little bit surprising. Um, because the other thing is that you can also run Portainer agent, which is a separate thing. So let's just look it up quickly. Portainer versus Portainer agent. Manage Docker on a host. Can be installed on another host. You can just add other hosts of the agent. Okay. So the agent lets you manage multiple environments, local or remote, from the Portainer interface. Think of it like a company that has offices. Blah, blah, blah. Geez Louise, that's not the thing I should have. Because translucent has a normal Portainer, so what the heck? Unless it's because the one here has version higher than the other one. Ah, that might be it. Although that's just a minor version. So let me just connect to something different. I want to show everything. So let's go to. Oh, I don't even have it that way. Holy moly, this is what a mess. Total mess. I'm just quickly checking the. Oh, Taras. Hello, Taras. I noticed you now. How are you doing? I'm just stuck in deployment hell, DevOps hell. Something I absolutely hate. I'm quickly just checking how on earth I'm running Docker on Java to see what the heck is going on. I have three What the hell? The whole interface is different. Applications, Portainer. How is it configured? Driven information. That is not it. What the heck? QNAP has very strange interface for things. It's like, what the heck? This is marked as application, but not really. Does it show me at least image? Nope. It just completely refuses to do anything. 221.0 Alpine. So that's what we're gonna try to set here. 221.0-Alpine. And does it show ports I'm forwarding here? Nine thousand. I mean 8,000 and the other one. So everything looks exactly the same. Huh. So we're just gonna try to recreate it at that point. If not, I do not know what to do. Because started up is just not allowing to connect to it. Ay, 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 ay. So to do that, I need to get back to one of the terminals. Not this one. This one. And Tara says, I'm doing good. I have found a new interesting project connected to SQL. What is it? And Tara says, Docker is fun. For you, probably it is. For me, it's fun when it works. Which is most of the time, but not at this very moment. Okay, it shows it started, right? So in theory, I can just go here and what? It stopped working? What the heck? No logout, please. Just get me there. We started it, right? Yeah. We started it, and this one's failing. Data schema version. Oh, dear God. Stop the thing. Delete the thing. Go away. We just need to go data delete. There we go. Start over from scratch, please. That will probably force me to create a new account, all the other BS, but we can do that. No problem. Something temporary. Where is it? Just gonna paste this thing and this and that. No. Create. No. Okay, so we've got the local running, right? I can see the stacks, that container itself is running. So now how on earth do I connect to it? So let's try from Java. Okay. Let's just straight up. Can I just straight up delete this one? There's update environment, but that doesn't do much. Yeah. It just refuses. 224, I believe. Let me just check it on the side quickly. Yeah. That's correct. Just no, it's checked. Sorry. The verb name is inactive. Let's just straight up add environment. It's the wait, what? Add environment, right? Docker standalone via this Docker swarm, Kubernetes or ACI. Docker standalone agent. Oh, API. So it wants me to start up an agent? You serious? Linux and Windows WSL. Oh, it wants me to start on yeah. Yeah. It straight out wants me to start up agent. Okay, I did not expect that, to be honest. But we're gonna try that as our last effort. Okay. Blah 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 blah. Taras says Docker is more fun than looking into some weird server no one knows how to configure. Yeah, because here you can figure out how to configure if you know what you're doing. So container agent, and we have that thing here, right? So in theory, I already have the agent folder, but I just want to see what kind of configuration I have. This will be on the right side. So we have agent, and it wanted us to create one with 221. Okay, there we go. And port just 9001. And all that fun part. This to that, which is exactly that. Exactly the same thing. Whatever that's about. But hopefully we don't have to worry about that. Sure, let's try to start that. Docker compose up. And I didn't add a D. Okay, so let's stop and add D so that it runs. And here it says it runs and that it doesn't have any specific issues. So now probably it will just magically work in our setup here. So I'm just gonna go to home and now it shows it's up. Seriously, that's all it took. So this other thing, but this other thing isn't running out of Portainer, so I don't know. Translucent? Translucent is fine, it's just we can't start anything there. That's the thing. So with this one, with Homelander, I've got an idea. You know what? It says, do you use WSL? Yes, I use WSL for Docker. That's like the only way to actually get it running on Windows, where you don't want it to run weird Windows containers, which are very weird. I just got an idea. Instead of trying, because our Docker compose file for all those fun parts, right? We can close this one, we can close this one. Our Docker compose for something like translucent, we're explicitly specifying where to store the data, right? Like volume, just use it here or something or something. What if I just don't specify it? Like run it on a whatever the automatic thing that Docker gives it, because Docker has that ability, right, where it just creates the volumes for you if you don't bind them to anything specific. So we could use that. So just manages that automatically, and we just don't have to worry about it, because essentially we'll be destroying them and creating from scratch when we want to rerun some kind of something. So let's say that I give this to AI and ask to do that for me because I don't feel like searching the documentation. Let's start a new chat, and I have the following Docker compose. Okay, I'll just give it this thing. Doesn't have any weird stuff. So now we're gonna ask it, can you please modify it so that the volume doesn't specify any specific host directory. This way Docker will automatically create a temporary volume. And always answers with certainly. So, wait. Replace the host specific volume mount with this thing. Okay. Volume section at the root level of the compose file to declare the surreal volume. Oh, okay. So it just has that. Great. Uh, is it okay if I have multiple services sharing the same folder from within the Docker Compose file? Does it introduce any performance overhead? Because that's another thing if they're all sharing that. It's fine. However, performance sharing volume typically does introduce significant Docker uses efficient mechanisms. Okay. Currency, blah blah. Okay, so we're good enough. And I don't care about drivers, so we're good. Okay, sure. We're gonna do that. So instead of running it manually, let's get back to our thingy here, and we're gonna utilize it a little bit better. All right. So we're gonna leave all those, and in volumes, we're just gonna specify that this is the Surreal data. Sure, that's good enough. And at the end, after services, we'll just have this volume specified. Yep, I remember learning something about that years ago. uh, and Tara says, when will you have time to take a look at an SQL page? Whenever you want me. Is it a website or something? SQL page? Okay, so potentially this is gonna suddenly out of nowhere work on translucent. Is that possible? Translucent. Add stack. Surreal benchmark. We just paste it all in here, and we just need to specify our variables here. Just the root user and some password. There we go. Let's see if that works. If that works, I'll be really, really, really happy. Oh, wow, okay. That did not look happy. The attribute version is obsolete. It will be ignored. Please remove it to avoid potential confusion. Network serial benchmark default, create a network, blah, 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 blah. Create a volume. Okay. Oh, creating container. Are we creating a response from them? Container name is already used by. Okay. I guess I still have that other thing running. That's what it is, isn't it? We started here and we never stopped. Docker, right? Docker compose down. There we go. Like an idiot, I left everything running. And let's take a moment, go there. And permissions denied. What the heck? Okay, that's rather shocking. Let's try it on Homelander. Add stack. Surreal benchmark. Okay. And we should be able to just grab the same whole thing. Come on. Surreal benchmark, that's fine. All this is fine. Um, oh, there we go. Deploy the stack. Let's see what's gonna happen on this end. Okay. Got the same error. So, yeah, I guess. Jeez Louise. What is up with those things? Hmm. So let's say that I'm gonna give AI the last chance to redeem itself. Because let's specify how to do that. All that, right? Great. I'm getting this error now. Okay. My YAML. And we're just gonna give it a little taste of it because that's what it is. And here we're just gonna add the ending, which is just that. This is running on container, by the way. Okay. I don't expect to have anything. And Tara says, I should have written it like, when you will have time, please take a look at SQL page. English bad is mine. Hmm. I'll take a peek after I solve that. So the error you're encountering suggests that SurrealDB process doesn't have the necessary permissions to write to the data directory inside the container. It's likely due to the default user, blah, 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 blah. To run the container as the root user. Can I do that? And if that doesn't work, you can try creating the directory with the correct permissions on all that BS. But it's supposed to do that for me. Unless I don't need to worry about volumes at all. How on earth does it work? So I'm gonna run yet another variant. This is so silly. So file is /tmp/ this data or opt or something like surreal data. There we go, because this should and no volumes at all. Because how many times was it where I run some kind of container and it just work on its own in the background? Somehow it saved this data somewhere. But at this point, I'm in the dark. I have no idea what I'm doing. Just no idea what I'm doing. They have their own image. They do not have official Surreal Docker image. Yeah, that is an official one. Yeah. Yep. It's just for some reason I'm getting constantly errors with all this weird stuff. Oh, and here this worked. So I guess I can just have it like this. For the tempfs. Tempfs. There we go. And there was one more tempfs. This one. No idea what I'm doing. So that's great. Let's just get rid of the other instances of volumes because we don't want that. It's yucky. And that was supposed to be this thing. Okay. Tempfs memory. Okay. Let's try that. I'm out of ideas. Totally. Where it go now? Here. Pertaining Homelander. Let's go back to stacks. this one, edit, and just paste this whole stuff and hope for the best. Update and redeploy and everything. Okay, it started. And what? This is the same thing? Yep. It just won't. Surreal CLI. Again, permission denied. So, yeah, I straight up don't know what to do with that. Straight up don't know what to do with that. Root user. Some password. And we'll deploy it here and probably won't do much either. So first of all, let's just straight up stacks this one, stop it, okay? Because it doesn't work. So now I'm just gonna go here, new folder. This will be Surreal Bench. Sure. Yes, trust. I hate this whole trust thing. So let's just add docker compose.yaml. Paste it, save it, and we're gonna run it. Docker compose upd. Okay, in theory it started. I'm gonna go to containers, and we have the same situation where it just can't. So I don't know what's going on. I don't have time or nor patience to debug that right now. Wait, we have only one deployment of the whole thing? Nothing else works. What the heck? I must say that's a new problem for me because everything usually worked. And this thing just added extra slash in front of it. I wonder if it's because of that extra slash. So wherever I have this, if I'm gonna just delete this, save it, compose down, and back up. Yeah, same thing. Now it's good, but nope. It's just, nope. Oh well. Gosh, it's just so tempting to keep tinkering with it. But if we have one deployment, we might as well just do that. Okay, we have one deployment of all 8 containers. So I'm just gonna close it all down because nothing works here. In the future will be those 4. Okay, right now we have just Java running. Okay, there we go. Right now it's just running on Java on the slowest thing that we have, but it should work. So we're gonna try to connect to it from Surrealist for now, just to verify that everything works. StreamingDB won't work, but what we can do is duplicate it and start editing. So this will be Java LAN, and let's see our numbers. So Surreal1 RocksDB will be on 38. Okay. This will be root user, and this will be some password. Good. Good. Okay. And group will be, sure, streaming, whatever. So we're gonna save it. Will it work? when we go to, wait, not this one. Okay, so this should be Surreal 1. RocksDB. Save. And let's switch to that one. We connected. Unsupported database version. Okay, at least it detected that it's an older one, but it's still here. Good. So in that case, we can start duplicating this particular one because the next one is RAM with number 1 larger. RAM. Save. Can we connect? Wait. Oh dear, we just edited the one instead of duplicating. Looks like I'm a little bit of a derp today. Come on. Okay, we've got RAM. Save, so we can connect to that one. Yes, that was nice and fast. So that means we're gonna duplicate it and call it memory. So this should be the in-memory one. It's 40, right? Memory 40. There we go. Save. And I didn't override anything, right? Yes, we've got a memory. We could connect. Great. So we have 1.x finished. And now we're gonna go with the Surreal to RocksDB. So yeah, we go here. This one, duplicate, and we're just gonna make it number 2 because this should be 2.0. This would be 41 as I understand. Yeah. And save, and we connect to it, and we don't have an error. Great. So next one will be its RAM version. Okay. And that will be number 2. So we go to RAM, and there we go. Great. So 43 will be SurrealKV. SurrealKV. Alrighty. Can we connect to it? Yes. I've got 2 more. KV RAM. And we can connect to it, right? Yes. There we go. And last one, 45, will be SurrealDB 2.0 in memory. So we'll call it memory. And that's 45. Save. And let's try to connect. And we connected. Okay, so we have 8 instances running. So that's great. We have new version of this guy available. So we're gonna do it. Okay, in the meantime. There we go. And what the hell just happened? Are you serious? So this just removed everything that I had just saved and brought back things from Surrealist 2.0. Because when I upgraded from Surrealist 2 to Surrealist 3, I was upset that it didn't reuse the settings and it just overrode everything. And now I guess we upgraded to newer version of 3 and it just brought everything back. So that means that everything here doesn't work. This is gonna be a long day or a long stream. Like, what the heck? Oh, I just delete those. Delete. 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 Duplicate. And let's get through this hell. Not that. Edit. Why was I tempted to click update during the live stream when everything worked? This is punishment for gods from gods. Surreal one. RocksDB. So what is everyone doing today? Tonight or this morning or whatever it is? What's everyone's plans for the weekend? While I'm suffering with this thing. Oh, now it doesn't connect? 48, 49. First one is 38. 14, 838. That's all good. And now I can't connect to it. Are you serious? Oh, now it connected. Looks like the 302 is more buggy than 301. Duplicate, edit, and there we go. Okay. Metrolet says, I'm going to hopefully watch the heat wave end in Korea. That's my plan. You'll be able to actually watch it. Yeah, that's awesome news. It started getting cooler here as well, and I was actually able to go and play some pickleball and not just get, soaked in sweat just from standing. So that's progress. That's glorious progress. Come on. And Tara says, I'm planning to do some taxes, and psycatch. Psycatch? Not sure how to pronounce it. And continue looking for a job. By the way, today is only Wednesday. Wait. What the heck? Why did I think that's a weekend? That's true. Oh my goodness. I guess I'm thinking of streaming that it's Friday or something. Oh dear. Yep, it's that bad with me. Okay, we've got those three. And let's continue. So this would be 42. So this would be SurrealDB 2, RocksDB, and number 3 in here, or number 2? Yeah, that should be number 2. Save. Let me just check if this one is... Okay, so they're correct. Cool. Okay, disconnected, and we just keep duplicating, and keep advancing the number up. Okay. At least it's not a lot to edit. Although I want this to be maybe lowercase letter will be nicer. There's never enough OCD. I have no idea why I thought it was weekend. I'm asking, what are everyone's plans for weekend? Oh. I have so many things to do that I don't know what I will start on weekend, actually. I need to rotate tires in my current car because I'm too cheap to go and get it done somewhere. Then wait, RocksDB RAM should be number 42. While I have 43. Wait, what's going on? RocksDB 38. 1 RocksDB RAM 39. Then we have memory. Ah, look at that. I skipped a number. Then SurrealDB. RocksDB, it should be 41. There we go. This one should be 42. So now SurrealKV will be 43. Okay. So this one works, right? Yeah, good. So now SurrealKV RAM will be 44. And the last one, Surreal 2 memory, it's 45. Save, and we have it here. Okay, so we have all 8 instances for testing done. Cool. And Michelle says, oh yeah, Georgia has low temperatures under 20 again. It's nice. Is it under 20 now? Maybe, because right now it's 69 Fahrenheit. What is 69 Fahrenheit to Celsius? 20. Okay. Because it started getting cool. But we're definitely not under 20s. Unless some nice weather is coming in a few days. That will be glorious. You might be finding Georgia as a country. That sounds like that temperature that will be there. Okay, so if that's... Okay, so we're connected. Now we need to figure out how to figure out our benchmarks. Because the thing is that we want to kind of be able to repeat stuff over time, record how fast it was processed. The good thing is that SurrealDB kind of sends us how long it took. Possibly. And then what else? And then we simply need to repeat it. Repeat that several times. So I'm thinking that instead of just manually copy paste and doing that in here, we'll be able to just use our Surrealist to just develop something that works step by step that we can deploy. And then what we can do is just a little bit of JavaScript that will run those step by step, making sure that everything works. And yeah. And start measuring there. I just dump the data afterwards. And there says, there says that I had an interview with Amazon today, with the recruiter. With Amazon, well, I heard that they just switched that you need to go into the office from 3 days to 5 days. And there are mixed feelings when it comes to Amazon. They have a very particular way of working, I think. I don't know. I don't know. You'll figure it out. Anta says, why do you need to rotate tires? Aren't they rotating by themselves? Yep. Tarzan's in a joking mood. Yeah, I need to do that in the truck, and then I need to fix brakes in a different car so that it's finally drivable. Because, I don't know, they start leaking and you can't brake anymore. Fun things. So I need to lift it up, figure out what the problem is, and how we can fix that. Okay, so maybe before we're gonna start building the whole thing, let's try to do something simple. We're gonna go to the RocksDB because this is like a normal thing. And can I use the unsupported database version? Gonna run it. Oh, I need to specify namespace, so this will be a namespace manual. Okay. And database will be test1. Okay. Run it, and we can get it. Okay. So looks like the basic stuff we'll be able to do straight from here. Okay. The heck are those? Great. So we've got the basics. So now, I mean, I'm gonna run it and it just goes into microseconds, right? So let's do something like this. We're gonna just create a bunch of data and then just get it. Like, give me everything. And let's see if that makes any difference. So we're gonna do something like create. We're gonna do test1, right? And this will be, let's say, 10,000 records, okay? And each record will have it set. The thing is that I can't even do anything specific there, but let's say that we're gonna make it. Don't we have like random or something? Let's delve into documentation. We're just gonna get like random number in a range, and then we'll be able to query it within that range, okay? Something real simple in the beginning. So let's go to the new tab. This goes away. Yeah, there we go. SurrealDB.com, and let's go to resources. I'm really missing the SurrealDB query language link here because we need to click here. And then, oh, look at that. We have the link here now. So this is not the worst because previously I was, okay, back home, and then the SurrealQL here. But that's me. I'm just going here nonstop. So functions, database functions, and I think we have random. Yep, random. And so random integer. Oh, that's actually nice. So let's say random integer for now. From number to number. Okay? Just like that. This should be good enough. Yeah. So we'll say number A is, and I'm not even defining in a table right now. I'm just going for it, okay? Random integer from something like -1000 to 1000, okay? And we're gonna create another one, number B and number C. And that will be our query. We'll just create 10,000 records like that. So I'm just gonna start making a little file here. This can go away. I'm gonna start making a little file here where we can start documenting those queries. There'll be queries.md. First manual benchmark. Okay. And sure, SQL, whatever. I should make it SurrealQL because we have that included. There we go. It works. That's good. And then we will basically need to start making a table, right? So we're gonna have version, time, and milliseconds, sure. So that's query time, right? But query 1, and then we have query 2 time millisecond. Because the thing is that this line will be considered first query, and then we're gonna go to another line that will be considered a second query. So that means that we get separate time for each one of those. So we might as well just do select everything from test 1. Select the whole table, okay? That's the first thing. And then we're gonna do select everything from test 1 where number A is larger than number B and number B is larger than number C, okay? We're just gonna search for all those records. Why not? And then we're gonna run once more. We're gonna say that don't select everything, just select number A as a result. Something like that, okay? So we'll have 4 queries. This way we'll see how it progresses on each version of the database. But I would like to start it with kind of a little warm-up thing. Return ready. Okay, we'll just wait for it to return the simple ready string, and this will be like the simplest thing ever. And I think this should be good start to just see if we get any results, right? So Q2, let's just do that without the whole time or whatever. It's kind of goofy. 3, we have 1, 2, 3, 4, 5 queries. Okay. So we're gonna do that, and sure. So I'm gonna copy this. Okay. So we're gonna start a RocksDB. Okay, the normal one. So I'm gonna run this query. Bam. Did we get any errors? Wow, this actually printed out everything. Oh dear. I guess they all succeeded, okay? So this thing, we can just first version is rock v1 RocksDB. Okay. We'll just start establishing this pattern. And that's the time. Second one, okay. Second one was 380 milliseconds. Okay, that's not bad. Then we've got 47 milliseconds to take it all and just print it out. Great, and we've got plenty of records. And then we've got query 4, which is find all those numbers. So that's not a lot of overhead. That's great. And then we've got query 5, which looks like it actually got faster if we didn't take everything. Even though we need to take everything to make a comparison. But also, I guess this will be purely because we don't have to return as much data, right? Because compared to this one, this is like a lot more of simply serializing, and serializing is probably the most expensive part here. So that's the first one. But then let's run it again. Oh no, but now it's gonna... So we can't do that. Delete test 1. We're gonna clear the whole table. Run. And that was the delete. Oh, we can just include it as a part, right? Come on, delete test 1. So that it's gonna clean itself, and that was 232. Wait, I can copy it. Milliseconds. Wow, that's a long time to clear everything. I guess that's what you get when you save data. Okay. Number 1. Let's run it again. And we're just gonna copy those and see how much it differs. Because from 86 to 44, 359, so that's more. Then, wait. Seriously, I can't hide this one. Are you serious? Oh my goodness, I can't do that. How am I supposed to know what the next query is? The last one got here for delete. I can hide it. Oh dear. This is combined. Individual. There we go. Number 2 is, oh, now I can't select the thing. 359, right? Okay. 48. So let's just have numbers. 48 milliseconds. Here was 48.1. Here is 0.6. This will be 0.9. We're just gonna round them like that so that it's a little bit easier to compare them. And I'll be able to quickly write them down. Okay. So here we had 0.6. Here was 0.4. And here's 0.8. Okay. So this number 4 was 54.7. Oh, well, very similar. Number 5 is 54.3. 54.3. Again, a little bit faster. Okay, and number 6 was 202.0. There we go. Let's run it again. And I think it did it already. Okay, 43.4. It's going to be the last one. 43.4. It's getting faster. Next one is 363. No, it's getting slower. 0.0. Number 3 will be more. And Mithrelite says, hey, on a video for the 2.0 launch, there's a comment asking if there is a NIM SDK planned. I mentioned you. Okay, thank you. I'll give a link there to that. That's funny that actually somebody wants to use it from NIM. Because with NIM, the thing is that there are just so many things missing. I think even nano ID, there's no nano ID generator or some other kind of ID for that. So yeah, sure. I'm actually excited for the driver because I'm kind of enjoying working on it. Now I'm trying to figure out how to approach getting the CBOR protocol. 50.4. Then number 4 will be 58.9. 50, actually 9.0. Number 5 is 59.7. And the last one is 207.56. 207.6. So all the numbers are kind of increasing. What the heck? I need to run it once more. 44.6. 44.6. Then we've got 405.2. Then we've got 54.9. Then we've got 62.7. And then we've got 61.3. And the last one is 209.7. I think I know why it's increasing, because even though we're removing those records, they kind of still take up room somewhere in that RocksDB. And that's what making it slow down. So I'm gonna run once more. 52.6. Maybe I'm gonna just put them side by side. That might be a little bit more healthy. Instead of me alt tabbing nonstop, I'm just gonna make this part a little bit smaller so it's easier for me to edit. So we got that one. Then that was 52.6. 52.6. Then we're gonna got 424.6. 56.9. Okay. 63.9. 63.5. And the last one is 218.3. So this is very interesting how the time it processes increases over time just because we make random 10,000 things. And even though we clear it up, record of them somewhere there still exists and blocks the database. Very interesting. And that might be also, I don't know. Maybe the hashing is slowing down because we're creating the same name over and over again. That might, but no, same name, it's not really, because all those records have random IDs. Or do they? So I'm gonna do 1,000 there from zero to, or from 1 to 10,000. Oh, so they don't have random IDs. Interesting. And Tara says, is this time to look at SQL page? What is SQL page? Is this a website or something? What is it? SQL page. SQL to web pages. That's what you meant? From database to data app. Fast. SQL page lets you build data-driven applications and a few SQL queries. It's free, open source, lightweight, and easy to use. Is this the thing that you actually wanted to do? Somebody actually had the same crazy idea. At the core of SQL Page is a rich library of components for tables, charts, maps, timelines, forms, and much more. You just populate the components with data returned by your database queries. Ah, okay, I see. So it's one of those. Okay. Written in Rust. Tutorial. What a weird page that is just like separate page. So download the SQL page executable for Windows. Wow, that's interesting. I mean, yeah, building the website locally. Okay. First SQL file. Select list as component. Popular website as title. Oh. Huh. And then select hello as title, world as description, and this as link. The first line of the file defines the component that will be used to display the data and properties of that component. In this case, we use list component to display a list of items. The second line defines the data that will populate component. And we can just straight up this as a link. And okay, so here we're basically making it the string stuff, right? And then we have create table users. Okay, connected custom database. And we have basically create table users. Select username as name, true as required. And then we kind of point at it, right? Form submit. Oh dear God. So there we go. Why not? And something tells me some companies really like it. Because this sounds like one of those projects where you have some small company that they have one or two people, like, or just one random guy that does all their Excel stuff. And at some point they got a database and they really want to get that out of it to get their own dashboards, but they don't want to pay for some custom solution. And one guy turns out to they know some SQL, and that's how they did it. That's what I can imagine in this case. Or because some things they just absolutely need to work as SQL. Because SQL is pushed in many places where there should be no SQL. Very interesting, but yeah. Okay, so while you're joining the project, you're gonna contribute? Because sounds like you're liking it. So the question is, are you planning to contribute? Okay. So you're gonna just take an example from how they did it, right? Modify it slightly so it works better for you, probably a little bit more open and flexible, and run both server and thing and do the thing in the Flutter. Crazy idea, like go for it. I'm kind of excited for it. I guess I'll need to learn SQL at some point. Okay, so we've got few shots of the RocksDB, and we know that this increases over time because there's some probably thing in RocksDB. So let's do the same thing, but let's connect to RocksDB that is supposed to run in RAM instead of running on and whatever you call it, instead of running on. Does it work? Oh, instead of running on the actual file system, it will run on a memory file system. So this is not the setting that is set for the, not a setting for the from SurrealDB itself. Okay, so good at that. Select database will be test one. Okay, and we run it and we got a response. Okay, so that's good. So now we're gonna shove that in and see what kind of response we're gonna get here. Very similar. I wonder if Docker still is gonna do some weird stuff with it. So I wonder if I can do this, and this will be v1 RAM. Okay, there we go. RocksDB RAM number 1. So let's take a peek at that. Can I like resize things? And not really. Table, live, okay, individual. That's where we're gonna go. So ready, we got first one in 70.7 milliseconds or microseconds. Then the second one will be 309. Okay, so just ever so slightly faster. 0.8. Then we've got 44.9. Like 45.0. Then we've got 51.5. Then we've got 50.7. And the delete was, whoa, way faster. 184.3. So that was the first one. Let's run it again. And we'll probably see the first one decrease and the others increase. 44.7, very close. Yeah, 46.6. Okay, then we're gonna have second one was 365. Oh, this increased a lot. 0.9. 47.7. And Taz is asking, you'll learn SQL? You're learning SQL. I will learn it eventually. But I think that will be a separate series, and I have some specific plans for that I want to see if it's gonna work out, because I might need to go through that like seriously, not only for myself but also at work. So I might actually make part of my like weekly workday that maybe I will like, you know, do 2-hour long live streams once a week, just to learn SQL for work. So that will be probably TSQL. So something your Taras are probably not familiar with, because TSQL is a little bit more different. So number 4, 1, 2, 3, 4 is 54 point, wait, geez, 54.5. And then next one is, whoa, 73.2. What the heck's going on here? Why is there such a difference? And 201.8. Huh. So let's run it again and just see how much different it is. This is exactly 53. The one that doesn't really matter. Here we've got 368. So it's going faster than not in memory. I wonder if Docker is doing some weird stuff. 51.3 and 57, not 58.0. Here we go, 58.5, and suddenly decrease here to 196.4. Go figure. We're gonna do it 2 more times, right? So that we have the similar thing. And I wonder if the SurrealDB, like natively in memory, is gonna make any difference. Because, I mean, this is not a small data set, but not a large one either. 424, holy moly, this is a record now. 0.8, slower than not in memory. Yep, this is getting slower, way faster. 0.9. And there we go with 70.97, so 71. Oof. And 104.9. And the last one was 209.7. Okay. And the last run. And why does it have something like this here? Not sure about that. So now we're gonna go with this one. So last run was 52.2. 403. So it goes down a little bit. Then we've got 57.0. And we go with 64.3. Still steadily increasing. Maybe not steadily, but increasing. And 0.9. And the last one is 213.3. Okay, so this is 5 of the runs of this one. So now we're gonna have, again, 1.0. I mean 1.5.6, but yeah. And Taz says Microsoft, yes, Microsoft SQL Server. That's something that I'll be probably learning. So yeah, they have their own approaches and their own million interesting things in there because it's just massive. I know that personally I would probably prefer to learn Postgres because, you know, it's free, it's more fun, and I don't know if it's better documented or not. I have no idea. Okay, so we went through that one. Let's go to the proper in-memory one, okay? Again, we're going to wake it up with this thing. And let's just go straight to running the test, right? So, oh, we need to specify the namespace, of course. Namespace will be manual. Database will be test1. There we go. And we run the query. Okay, this might be a little bit faster. There's a chance, right? So it'll be 39.6 for the first response, which is actually pretty fast. Something that doesn't actually require the data to be accessed. 0.7, that's good. Then we've got the, let's just go to the individual. Number 3 will be 43. Okay, it's just very, very, very little faster. 49, so again, barely any difference. Actually slower than this one for this particular run. And this one was 53.5. And this one will be 100, which is actually really fast for deletion. Okay, so something tells me that because this is in memory, the RAM was exactly cleared, and suddenly we won't have this regression where RocksDB is making the performance decrease over time. That's my take on that, okay? My expectations. So let's run it again, and let's see if that's true. Why is the first query, the return ready, something that doesn't access any data, slower depending on backend? What the heck? That's an unexpected one. 216. Wow, this got faster for a change. 0.7, yeah. 43.5. Then we got 50. 0.4. 50.5. 0.6. And 102. Okay, so this is already something that isn't increasing. So that might be it. Run once more. I just need to get through those times quickly. 27.9. Next one is 251.0. 43.1. I probably should start going straight into a spreadsheet, shouldn't I? 53.5. This one will be 53.9. And the last one will be 108.5. Okay, this is going pretty fast. Okay. I'm very much enjoying that difference. But I'm really curious how this will compare to SurrealDB 2.0, because that's where the performance increase is supposed to happen, right? Better query analyzer, better bunch of stuff. So I'm looking forward to it. And this is really manual. Really manual. Next ones we're gonna run automatically. Okay, we're gonna make something quick in JavaScript most likely, because that's something where I can whip something out as fast as I can. And I don't think JavaScript will be slowing us down much, especially that we're gonna just trust whatever data SurrealDB will send to us, rather than measure on a JavaScript side. 102.3. There we go. And last one. Okay. And 3.5. And what do we have here? 30.8. Then we've got 227.9. So it kind of started increasing, or no, decreasing, it's just jumping around that one thing. 42.2. And then we've got 50.6. This one will be 49.2. And the last one is 112.2. Okay, this is really good so far. So the in-memory actually increased things significantly. Like, you know, twice when it comes to deletion, maybe 1/3 when it comes to creation, and it isn't slowing down as the time goes as much as the other things. So that's kind of the garbage collection. So what I'm gonna do now is I'm gonna just grab that and just turn it into CSV. Can I just do something like, I don't think that works. Nope. This is just JSON. We don't want it in a JSON format. Okay, I'm gonna copy paste it because I want it as CSV. So we're gonna, fortunately, I think it's gonna be easy to change that. So for all those, we're just gonna do this. And now for all those, we're just gonna make them into those. Whoa. And the same thing for all those. Okay. I can get rid of this thing and that thing, and hopefully I'll be able to copy and paste that part. So let's get something like Google Docs and we'll try to create it there. Let me just quickly create a temporary file. New Google Sheets. And let's just try that. Okay. Can I just paste it? Ooh. New file. Like here, new file. Query 1.csv. Okay. I'm just gonna straight up do that. Add the thing on top, because I don't want to copy paste value by value because that will make me not happy. Okay, and I mean that looks like a valid CSV, right? Can I import a CSV? Insert. How the hell do you import a CSV? Transpose data validation, conditional formatting. What the hedge? Not this one. Let's go here. Google Sheets import CSV, please. File, then import. There's no file import. Oh, here on top. Jeez. Not that. Upload. And let's just grab the file. Here. Separator tab. Custom. This is the separator. Replace current sheet. There we go. Text to numbers, days to from sure, whatever. Okay, we've got that. Good. This is progress. Okay, this is progress. We'll be able to live with that. Okay. So we make it a little bit shorter. There we go. And okay, now be v1. v2 RocksDB number 1. Okay. And there we go. We're just gonna put all those numbers in. This should actually make number input a little bit faster. Okay, so we've got 2 RocksDB. Okay, we're gonna do the same thing where the namespace will be manual. Then database will be test1. We just run this query to warm it up. Good. We're all good. So now we can paste this and run the first query. Okay. Whew, so far it's gonna be slower. We'll see. So ready got really slow. 75.6. Then here will be 417.9. 65.6 and 89.4. Okay, so far it's significantly slower, 91.8. And here will be 234.0. Okay. So, wow, okay. Can I just replace this from nanoseconds to something? Final replace. Wait. Actually micro in here. Okay. So, and here we're gonna do file. Find and replace. Microseconds with nothing. And replace all. Done. The same thing with milliseconds. Nothing. Bam. Okay, that starts to look like numbers. Let's just make sure that those numbers are formatted correctly. We want to have always one decimal place. There we go. Okay, so another query. Let's see if this speeds up. 58. Actually 0.1. Then we've got 451.1. So this is slowing down way more, to my surprise. 6.2. 98.8. 104.9 and 233.7. Okay, so this is surprising. Next run. I mean, did I configure something wrong or something? 479.9. Then we've got 69.1. 95.4. 102.9. And we've got 245.3. So this is not great. This is like a lot slower than 1.0. Maybe it speeds up in complex queries instead. But so far, I'm surprised. Even the normal query of just a single number is slower, which is surprising as well. And how much it varies with just return ready. But I wonder if it's something to do with how I deployed it. Because I don't 100%. I mean, I'm not sure if that's true or not. That's why in a second we're gonna go back to the first one and see what happens. 105.41, and that's gonna round it up and down for me, right? 300.97. There we go. And one last one. 46.92. 478.24. 74.46. 103.02. Gosh, this is still increasing. 101.2. And last one is 262.65. Okay. So basically on every aspect, it's drastically slower. Huh. I did not expect that. So let's switch back to RocksDB on Surreal 1 and run this query. I want to compare the numbers. That is slowing down too. What the heck? I mean, 484, 61. I mean, faster than the other one. 67. So it's kind of increased from the other one. Then we've got 66 and 227. So it's an increase, maybe because of warm up, but still nothing like this. Because when I'm gonna go to RocksDB here and run again, it's 575. What the heck's going on? Run again. And again. And again. And again. It keeps increasing. It goes slower and slower and slower. Oh, it's reaching its limit. It's getting more consistent. Nope, it's still increasing. Holy moly. So basically now creating 10,000 results is basically, what, 800, nearly a second? Holy macaroni. Okay, this is not great. I mean, we're edging on 1 second now. It's as if it was trying to clean something up in the background, but not really. Yeah, we got to 1 second. Huh. Again. So for the first thing is fast, then we have whole 1 second to, while in some other cases, like RocksDB took, in v1 took 318 milliseconds, so a third of the time. And in memory was a fifth of the time. And that slows querying down too. Huh, very surprising. So let's just compare it to something like RocksDB in RAM. Namespace would be manual. And database test1. Start that. It works. So we can copy the query and check this one out if that's gonna change anything about it. Although I doubt it. But it's one of the things I need to measure. v2, RocksDB, RAM number 1. Okay. Gonna make a nice diagram out of that. Okay, so we're on the first time. $70.97. 387.58. 62.67. Yeah, I'm just gonna try to run through it as fast as I can. Just to get those results as fast as I can. Ghost Magic says, are you doing that over network using some cloud provider? No, right now I'm hosting it on one of my servers at home. It's a dinky little thing, so it's a little bit slow, but maybe that's actually good. And over network is basically, right now it's 10 gig network local, so it's really, really, really fast. So somewhat local. I had trouble deploying it on other devices for some reason. Due to my Docker inadequacies, me not being good with Docker. I will need to investigate it, and I'll probably have another live stream on continuing with this whole benchmarking with a little bit more of a setup, because I wanted to repeat the setup on 4 different devices. So I have 8 instances, various instances of SurrealDB on 8 different devices with different, different configurations, different processors and whatnot, and maybe even cloud at some point. I would like to do that once I get something automated. Because, on different hardware, it will run very differently. But right now I'm just tinkering to see what happens, And I just want to see if this is gonna be increasing or decreasing for this one. Because so far it's increasing drastically. Like, what the heck? I'm starting to suspect that there's something wrong with my server running those instances, because it's weird that it's increasing so much. Like, we're already at 515.51. That isn't right. 74.56. 101.24. And 100.95. Then we get the last one, 266.85. Let's just run 2 more queries. 2.83, 39.87, and 97. Come on, 97.0 and 263.1. Okay, and we have one more to run to see what on earth is going on. 480.48, 76.21, 101.6704. What, I don't know why I'm putting the whole number. 101.8, and last one is 250.73. So this is kind of overhead, but it's stabilized for some reason, although this is still increasing. But this whole RAM thing here is kind of a sketchy thing. So now we can move on and check how the SurrealKV is faring compared to everything. Because that's the thing I'm interested in. Because my initial testing was showing that SurrealKV was drastically slower. But considering that it's early beta, then, you know. Okay, manual for namespace, and this will be test 1 for database. Run it, it's all good. Cool. So we can run it here. Oh, that is thinking a long time. See how long it thinks to run the same query? That is so strange. KV number 1. It's still running that query. Holy moly. Okay, individual. So this is within norm, right? 54.9. Then creation was 489.97. First query. Well, what took so long? Because that took way longer. 0.0. Then we're waiting 302.22. Here we're waiting 360.23. And deletion took 17 seconds. What? .83. Holy macaroni. So we're waiting 17 seconds to just delete the data. Okay, so while this is vastly slower as well, so that's interesting. Huh. Let's run it again. Although it's gonna take a while. But I want to see if it's increasing just like all the other ones. And Mithridate says, can you try one of them out in a CLI for comparison? Pretty flag with show execution time. I can figure that out, although I don't have a CLI for SurrealDB because I never installed it. Although I could go jump on a Docker container and probably run from there if the Docker container includes a CLI. I'm the kind of guy that usually skips the CLI tool for things. Okay, so let's compare this. 29.86, so that's a nice number. 524.23, that's not a nice number. 284.16, that's a little better. 303.64. 295.44. And the last one will be 20191.11. Okay, this is going a little bit slower. Hey, we're halfway through, right? I'm gonna note it down. We're just gonna go through SurrealKV running in RAM and then just in memory, which should be fast. And we're gonna see where we're at, okay? And then I'm gonna figure out a CLI. Okay, this worked. Let me quickly copy the number. Okay, we're not increasing as much, I think, as the other ones were. So that's an improvement. And that does additionally all the other stuff. So it tells me this whole delete thing takes so much time because we need to keep those versions or something. And that probably does copying data or some other weird stuff. Huh. But again, it's just deleting 10,000 records that don't link anywhere. Why would that take 24 seconds? And it keeps increasing. Okay. Yeah, it's slow. I'm actually not deleting the table. I'm just deleting all the records. Delete test one. That doesn't remove the table. So removing table will be probably actually fast because that means we wouldn't keep all those version records behind the scenes. Okay, 425.1. 377.38. Okay, it is increasing. Kind of. 0.53, and this took 26 seconds. Nearly 27 seconds. Okay, and the last run, the fifth one. Wait, we didn't get anything? Oh, because I had selected, right? Yeah. Sorry. I mean, some of the data, like those selection ones, they are fluctuating because we're selecting depending on the randomly generated numbers, but they were roughly the same thing because they need to scan the whole table anyway. It'll be interesting to modify this thing by creating this index on this table and see how that changes. So that might be another thing to do here. Okay. Let's just put in those results. And we go here. 419.62. 412.47. 424.95. 28.28. Okay, so this is this pure SurrealKV. Now let's switch to SurrealKV, but in a Docker's RAM disk thing, which we found that is not always speeding things up. It's kind of keeping them the same or a little bit slower. But I wonder how this is gonna change when it comes to, you know, SurrealKV. So it'll be v2 SurrealKV RAM. Okay. Again, we need 5 samples. And let's run the first one. Okay, it's still the deletion is still taking a long time. Yeah, it'll be fun to also, at some point when I deploy it as multi-node or something, to run tests on that kind of stuff. Or those could be also automated as, because on GitHub, when using GitHub Actions, you could actually deploy Docker containers inside of those GitHub servers to automatically run tests. So if you would run several actions for testing different variants of the database, yeah, this could be doable. Interesting. And just run periodically, and that's it. So I might get to that point at some point because I kind of find it fun right now. It's interesting to learn what is fast, what is not fast in a database. Okay, 477.99. Okay, so that's marginally faster so far. Oh, 189. Look at that. So this is speeding up. 190. So that's because it doesn't access the drive. A reminder, this unit that I'm running this on, it actually uses ZFS file system that's like 8 hard drives, normal disk hard drives, but they're backed with the SSD cache layer for read and write. So yeah, a different kind of solution. Not your usual environment for a database, although at the same time, a NAS is a good thing for a database, right? Run it there. Okay, and that's in seconds. So 17891.75. There we go. Let's run again. And let's see how much it's increasing, because this number is very similar to this one. But those numbers for querying are faster. Interesting. Very interesting. So querying will be faster while creation will be roughly the same. And the same with deletion. Huh. Okay. Again, 470. That's good. 240. That's less good. 247. That's less good as well. And this one took already 582 milliseconds. Very surprising. I wonder what is causing that slow thing. That was 28 seconds. Yeah. Lost something there, but doesn't matter too much. Alrighty. Okay. 465.1. Okay, this is pretty stable, this creation type. Creation time. To my surprise. Then we've got 270. And the last one is 23865.39. Okay. And we've got just 2 more runs. Microseconds, milliseconds, and all those. Okay, there we go. And this is still thinking. Oh, it got a query. So it'll be 41.3 microseconds. 517. I spoke too soon. It's still increasing. Yeah, we got to 301.6 already. 344.14. 372.8. And the last one, I'm gonna start the query already. 27467.8. Whew. Big number. But at least we're going through the last round of SurrealKV. I wonder how SurrealKV will fare in a little bit more complex queries. Because, again, we're just doing some really easy stuff. But what when we're going to add indexes, when we're going to add more things like, relations. So that's the part where it's going to start getting interesting, and we'll probably start seeing pros and cons of different solutions. This is steadily increasing, yeah. 296.41 and 294.66. And the last one, 28726.45. There we go. Okay, now time for v2 in memory. Okay, that should be the fastest. Here, let's just do in memory. There we go. Okay. So in memory, again, 5 samples, but hopefully this is where we're gonna finally get some more workable speeds. And database, we're gonna make test 1. There we go. We get the answer, right? So that's all good. So now let's get our query, and bam. That's a little bit faster, right? Okay. Okay, wow, this is still pretty slow. 0.9. After that, we need to run the in memory, but for the 1.0, because I want to see if just me keeping running things here is actually slowing the whole unit down and kind of was, maybe making the later runs a little bit more favorable. I mean, the earlier runs are a little bit more favorable, possibly. But that's the thing that I don't know. We need to gather data to figure that out. Okay. 332.64. Okay. Oh, 59.58. That's better. And 85.99. Last one. At least deletion is fast in memory, right? 0.13 second instead of 28 seconds. Okay. And we do 28.15. There's so much clicking. We definitely need to automate that. 92, and then we're gonna have 89.67 and 137.15. Okay, 2 more runs, and we're gonna be done with the whole initial set of data, which is taking way longer than I expected, to be honest. Like, way longer. And results are also different than I expected. Okay, and I also want to check what if we're gonna run some data on millions of records. How would that differ? And the other thing is that it's all running in Docker containers, and I don't know how much SurrealDB is optimized for that, because maybe that has its own set of inefficiencies. But I can't imagine running database in a different way nowadays. Everyone just deploys a Docker container. Okay, and last run. .15, 68.85, 96.36, 96.49, and 161.03. There we go. So we got our first set of data. But I really want to go to SurrealDB 1 in memory and run the same query. Holy moly, it's faster. Even deletion is under 100. So here, yeah. First one took a little bit longer because that was first query after the database hasn't been used for a moment. Then 229 within the range. 41 within the range. Actually, the best result so far. 54 within the range. 48 within the range. And 98, again, the best result so far. So it's not really slowing down, to be honest. The numbers actually are right. Huh. Okay, this is something that I did not entirely expect. Yeah, can I copy it and paste it into Markdown file without big problems? Let's just get rid of this thing. Not the best option. Can I just maybe as Markdown? Ooh, that is not Markdown friendly. Why does it? Seriously, it copies it as table? Oh dear. HTML origin. Oh, I know. We just... Oh, Control-Shift-V pasted it as HTML. Wait. Preview queries. What the hell just happened? Control-Shift-V switches me to preview? That's supposed to be paste without formatting. That's a new one. I paste it here. I copy it like that. And try to paste it as Markdown. Nope. As JSON. Nope. Whatever. I'm just gonna have it like that. I'm gonna find something to format it later. I'll probably just delete it from here, you know. I'm gonna format it nicely at some point. Okay, so if that's the case, I'm gonna straight up need to make some kind of project to run it. Okay. So how about we set up a project? But how are we going to do that? Because we need to be able to run it and dump data in some kind of specific way. And I will also like notification of how far we're going through. And we need to load JSON configuration. Okay. I guess we're just gonna use bun. Sure, let's use bun. We're in Surreal benchmarks. Bon init. Wait, bon version. I have 1.1.13. Let's see if I need to update it or something. Where on earth is that browser? Here. Bon version. What bon JS? There we go. Bon 1.1.1.128 is here. How do you install it? Oh, bon upgrade. There we go. If that's enough, I'll be. Yeah, that's it. That's all it takes to upgrade the new version. Okay, I love it. What kind of help do we need? We just have init or something like that, I presume. Run, blah, 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 install. Init. Start an empty bon project from a blank template. There we go. That's what I need. So bon init. Minimal project. Package name, serial benchmarks. Yes. Index.ts. Sure. There we go. Okay, we've got our project set up. So if that's the case, let's close all those things down and focus on what we have here. So we have our package.json, right? And Mr. Reddit says, I've been trying these out too. Have added the let nothing equals something in front of every select to remove the output. Okay. But at the same time, when I'm deleting, there's no output, right? And to remove the output to basically not serialize it. Yep. And oh, that's what you mean on all the selects. Yeah, that's an approach. Sure, I see. Why not? That's a good. That is a good tip. Thank you for that. Okay, so we've got this. That's good. Now, how the hell do we make it work? So we've got our index.ts. So we can run it, I presume, right? Dino bundle. What the hell? Run. No scripts found in package.json. Okay. Scripts. Start. Sure. Oh, it's just like that. Oh, okay. Bon start. Yeah, hello via bon. Okay, that's gonna be enough. I don't feel like making the whole script for whatever task for running it, but eventually I'll do that somewhere. Okay, so we've got that part. We've got our index TypeScript where we can do things like load. I mean, to do load the database, the list of databases from a JSON file, or we can just specify it straight in code, right? For now. So let's do that. Let's do. I'm gonna make some simple type. Okay. Let's say surreal or not. src. I'm just gonna keep source here, although it's already source. What the hell am I doing? Okay, let's create a file straight here. Or we'll figure out our guys later. Let's call it something like database.ts for now, and we're gonna make constant or like type database definition is. We're gonna have name. Then we're gonna have name is enough. IP, port, username and password, and that should be enough for our database, okay? So databases will have, there we go, RocksDB. Let's keep it as not localhost. 195.168.50.5, okay? Root user, and let's just make const shared username, const shared password, some password. There we go. So I'm just gonna straight up get that out of here. There we go. And we'll just have those going. RocksDB RAM, yes. Then we're gonna have memory, yep. RocksDB 2, RAM, KV, RAM, and memory. Okay, we've got this defined. That's nice. Awesome. That's some fast coding. And that's it. That's our database definition. So that's one thing. The other thing now will be to... So basically, we have the definitions. The other things to do will be define steps to repeat for each database. And then we're gonna have basically define the loop and also define how to dump the results. Probably a CSV file per database, something like that, right? So let's define the loop first. How we're gonna go through that. So the way I would do it is probably for const db of databases. Okay. Let's just do let databases. I mean, const, we can use it here. Databases. What was it? Databases. Wait, so I don't even need to do that. This, can I just import? There we go. Jeez, what is wrong with me? And Anna James Arts says hi. Hello to you too. How are you doing? Doing good. Just unexpected results of the database. So now trying to automate tests with some code, so I don't need to copy paste to manually run it a million times. Alrighty, so we've got the databases, so basically we can load up the data and then would be connect to the database, run each query, dump the results of each query. Okay. And then we're gonna do close the connection. Something like that, right? That sounds good. So now we basically need to start, the SurrealDB thingy. So let's go SurrealDB JavaScript. Okay. And there we go. SurrealDB SDK for JavaScript. And that's that, right? So fun, add this thing. Oh. What? Oh, because it changed name, right? The name was changed to SurrealDB JS, I think, on npm. I could probably quickly check by getting into this code. How on earth was I using it? Um, duh, 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 Anna James Arts asking, you're programming or gamer? I'm both. I'm doing programming on databases, on web development stuff, weird languages like NIM, and also a little bit of game development on Mondays. So I'm doing it all. And playing games. Recently did Satisfactory because 1.0 got released. So okay, where's the package.json? And Mithridat says, I know nothing about benchmarking, just for my own sanity, waiting through the output. Yeah, there's a lot into benchmarking, a lot of gotchas, but I'm gonna do it like, a simple thing. You start simple, then you can start adding more. SurrealDB. It's just SurrealDB. So where did the whole weird thing come from? So I can probably just go and copy this part. Okay. This one we can close. Oh, I just straight up replaced the other one repo with the other. Of course I did. So instead of trying to install this from there, where's everything? What? That's not the file I wanted. This one. Okay. Pure dependencies. I just want normal dependencies. Okay. There we go. And not beta anymore. This is gonna be 1.0, a normal release, which is again exciting. Okay. Package installed. Great. So let me just I can probably again copy code from here. Let's just open it in a new thingy. And I can just go to how we did it in this backend side. I haven't touched this project yet since the last stream. It was just simply no time. But no layouts, no pages. It was all in content. There we go. Sync collection. And we can just copy paste some code. So we got this, that, wait for collections, topics, blah, 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 check everything. And then we can finally at some point connect to the database. There we go. New Surreal, connect with this stuff. And then we have a little bit of trying to run a query. So this should be enough for us to get started, right? So yeah, so connect to database, run each query, and that. So let's just create a new file and call it bench mark runner. Yes, we'll just I want to type in proc like it's nim. And Anna James Art says your Discord server link is expired. Oh, I wonder if you got the link from the bio on Twitch. Is that because you're a second person that says that? Possibly it's expired there. Let me copy the one from the video on YouTube. This one should work. Let me know if this one works. If it doesn't, then Oh well, because I might have the old one on Twitch, like description or whatever you call it. I think there is something like that or whatever. So we'll see how that goes. And I don't have my code anymore. So let's call it maybe something function, export function from benchmark. DB will be database definition. And query string and iterations, there we go. Whatever is here, I'm just gonna do bam. Just paste whatever I had here. So database definition, what did I call it? Database def. Oh, I need to export it. Okay, there we go. And now I can import it. There we go, beautiful. And this will be from here. Yeah, good. And Anna James Art says, yeah, it works. Just join for a server, sir. Welcome to the teeny tiny community. There's not a lot of going on there yet. But hey, I'm not trying to build like a mega big community really fast or whatever, so that's that. Okay, so first we're trying to connect. First, let's also make it async function, right? So we're gonna create the connection, and then we basically need to see if it worked. So database connect, and then we have DB. Oh, Surreal URL. Really? URL or... Huh. Okay, so I guess we'll need to just... Let's just keep the shape that we already have. And I'm just gonna, you know, make it up. And this will be db.ip. Then we're gonna have colon and db.port. Okay, great. So that should be our connection string. And then what we have prepare. So basically what we're doing after that. So the thing is that we also need to provide what namespace we're running on, which database, and all this stuff. So I think that will be part of some kind of benchmark. So instead of query, I'm just gonna make benchmark will be type of benchmark definition. Okay, we're gonna define it in a second. So be use the namespace and sign in. So again, it will be namespace, database, all that stuff. So we're just gonna get const namespace is the benchmark namespace database, and this way we can just do all that, right? Namespace username will be shared username, of course. Export, sure, and export. I can clean up later. Let's just do it that way. This way I can import it, and it should be good enough. All right. So this takes care of those two in a little bit more cleaner fashion. And that's the connection. I'll screw the implicitly this or that. Can I make it ew. I don't remember how to ignore that initially. It should run without it though. And Anna James Art says, thanks for the warm welcome. Where are you from, by the way? I'm from Florida. US Georgia. And originally from Poland. That's why the accent. Okay, so What am I doing here? This is that part. Await this thing here, and we close this thing. Oh. Now it's fixed. And failed to connect to SurrealDB, and we just got the error thing. Okay, so that's good. And we don't have any weird loggers or anything, so we just do console log. Connect it and sign in to and just add a DB name at the end. Okay. There we go. Beautiful. Mr. Day says, I saw the surname is West Slavic and was wondering which one. I was betting on Poland, though, thanks to the population size. Ha. Yeah. Dudek is actually translated to Popo? How do you spell that? I forgot. Popoe? What's the bird name? Bird. P-O. Not poop. Great. Bird poop. Nope. What the hell? Hoopo. There we go. Jeez. Yeah, that kind of bird. That's me. Fun fact. All right. So getting back here, connected database to name. There we go. All that fancy stuff. So afterwards, so basically we connected the database. Then we're gonna have run each query in the benchmark and save run each query from the benchmark. So the thing is that we're gonna do it in a way that for query of benchmark queries, right? We're gonna basically do run query. Something of that sort, right? And then we're gonna get to that part. Metrodad says, learned a new bird word today. Yep. And Anna James Arts says, nice to meet you, by the way, sir. I also send you request on Discord, so kindly accept that too. Well, you seems really nice and kind person. Have a great day. I have to go for now. Do some chores. Got some chores to fulfill. All right, good luck with the chores. Hopefully they are not too annoying, because chores tend to be annoying from time to time. Okay, so let's get and define the benchmark thing. Benchmark TS, export type benchmark definition. So we're gonna have something like namespace and database, and then we will basically have the queries to run. Okay. For now. So queries would be query definition. Perfect. Export query definition. So we want a name for the query, because for each benchmark we'll kind of dump. We can imagine that we'll have data collect it for each benchmark, and then it's gonna be running each query separately. So let me think. So we'll have something like benchmark 1, query 1. And then we're gonna have something like db1 was whatever, 120 milliseconds, right? db2 and db3. And then we're gonna have another benchmark 2 and benchmark 1, query 2, or something like that. So the reason would be to be able to send benchmarks to multiple databases at once, if necessary, and B, to have it where we can basically, do some stuff properly. At the same time, maybe not, because our current CSV, when we look at it, it just shows that we have, this is considered one benchmark, right? We just had one benchmark. And we have multiple queries in here where they are progressing that way. I'm wondering if that table should be the other way around. Because how do we present graphs out of that? I'm going to select this. Can I make a chart? Insert chart. Right? And it basically shows me those. Well, I would prefer to have yeah, this is it. Wow, this is very different. Because the thing is that we can also show how much, gosh, there's just so much data to add here. Just so much. I think we're gonna just dump it in some kind of format that then we can turn into a database, right? And then learn how to query that data from the database to present it more nicely. So let me think. So we have basically a benchmark can have a number of queries. And those queries will be executed one after another immediately. Okay? And so let's do it this way. Because the query could be defined in two very, different ways. One is that, where is it now? There's the Surrealist. There we go. So our Surrealist, we can run queries like that. When we run this is a single query, but it will return, 6 separate little queries, or 1, 2, 3, 4, 5, 6, right? Because there are 6 statements here. But then we have the possibility of also adding the begin transaction or something, which I'm not sure how it's supposed to work. Is it per connection or something? That's one thing that I haven't really looked at. And in theory, one could have multiple transactions going on at the same time. So that will be probably something else to test. Like, what if we have multiple clients connecting to the database? In our case, we can just make multiple instances of the same of the SurrealDB object, I guess. I think that's what I would expect that the SDK is gonna do. So yeah, that is another thing to kind of figure out. This is non-trivial. So let's say that we're gonna make it a list of queries where each query could be a set of those, subqueries or whatever, those statements. I'll call them statements, things that end with colon. And usually you have benchmark with just one. But if we have multiple, we're just gonna keep basically adding them up. The question is, do we want one benchmark to return one file, or we want multiple files per benchmark? I would think we probably want one file per benchmark that we can then analyze and extract data out of. So in query definition, we're gonna add the query as a string, okay? And name of it. And that's it. Okay. And then we probably would need to have additional information inside the benchmark itself. You know, like some set of flags. So for one will be, for example, number of connections. So I think that should be another thing. So this would be something like the number of database connections to use for the benchmark. Each connection will execute. Each connection is each in parallel with other connections. Okay, something like that. So this will be just a definition here. Remember, the benchmark definition doesn't have any logic. It has just data. It will be up to our benchmark runner to figure it out. And we are probably not implementing that yet because we're just gonna do simple. Go simple right now. Okay, so our query definition of the query and name, and that's pretty much it. Okay, cool. Good definitions. So let's import it so it doesn't complain anymore. And here we're gonna start with just simple connection so that we can, you know, start out. We create a connection, and then we basically run each query from the benchmark. So from each query from the benchmark queries, we'll be able to run it. So let's define that. Async function run query. Run query. So we're gonna have the DB as the, or let's do connection as Surreal, query as query definition, and number of iterations. How many times? That's the thing. We want to run the queries from top to bottom. So if we run query like this, we can't do that. Okay. So in benchmark, I would like to also add iterations number. Okay. And this will be the number of times to repeat each query. Okay. Not repeat the benchmark, not the query. Okay, so that means that we will first need to go for const iteration array iterations keys. What? Really? Array.keys returns an iterable of keys in the array. Can I just do that? What the heck? I don't think I need a special iterable there. So for each iteration, we're going to run the thing. Okay. So we can do console log running iteration number or whatever iteration, right? Okay, so we're gonna, for each iteration, we're gonna run all the queries inside the benchmark from top to bottom. We're not collecting the data yet. We're just figuring out how to run it. Okay. And then when we run the query, what do we need to do? So when we run the query, we have to basically no iterations here. Well, we just need to run the query. So what do we have here? Topics, post series, we don't care about that. And that's just parameters. So we have results, await, database query. And we have our query inside. And then if success or not, we do stuff. So results is await and the connection query. And this is what we're expecting as a result. I don't think I'm expecting anything special. I could actually do query raw, because that's gonna give us the query the promise of query result of some kind of type, and I don't care what kind of type. And that means that we'll have access to the query result, which should give us the timing. And here we're providing with the query string and some kind of list of bindings which we simply don't have. So it will be our query.query. What fun naming convention. Okay. So results, and if results dot, oh, that's actually a list of results. Zero, then new error, or return no results. So we're just gonna stop it. Sure. For now, we're gonna add some more, what do you call it, resiliency later. But for now, let's do let success. So for result of results, then if result dot, so we have result status and time. Status is error. Okay, so do to, and then we can basically add result dot wait a moment. Status dot, okay, equals ERR. Okay, result dot message or something like that. I don't remember what it was. Query failed. For now. We can debug that later. But if we have success, we can basically say let, or const time is result dot time, and time is a string. Interesting. Okay. So we'll just say that query name took that much time for now. There we go. Beautiful. So this should be the way to run a query. We just run it, we log the time, and we can actually return the time. So instead of throwing, we're just gonna, oh, because it needs to be a list of strings, because how many we basically got back. So if there's an error, instead of just doing that, we're just gonna do console.error or return no results, and we're gonna return empty list of strings, right? Because we didn't get anything for that particular run. Then we're gonna have results. If there was an error, we just do console error, query failed. And we just show the whole result, because why not? And we're just gonna let's do let times is the string list. Okay, so we do times push error. Okay, and just continue. That's it. Otherwise, the time will be this. So we're just gonna say, print the thing out and say time push time. There we go. Resolve the time. There we go. Beautiful. Okay, sure. So this way we're actually returning a list of strings. And the thing is that if this, then that, and of course at the end we need to do return times. Okay, so this should be good enough. Why is it complaining? Must use the, oh, promise. Of course. Okay, so that means that when we try to run the query, we're gonna have the, what do you call it? Times. Like let times is just run it, right? Run the query. And we don't need any of that anymore. Okay. So these will be the times. So then we're gonna do, because that's for each iteration. For each iteration, we have a list of times. Gosh, that will be a lot of data. And then we have the benchmark. So the benchmark itself it should return list of times per iteration. So we're gonna make it that it's gonna return promise of benchmark times. What is the name? Benchmark timing result. Okay, so let's define it. Export type benchmark timing result. So what we're gonna have here is it's gonna be just a string, an array of strings. That's it. But we can probably just dress it up a little bit more nicely. So it's gonna be object that contains number of iterations. I guess it wouldn't hurt to do that. And then we're gonna have queries per iteration. Wait, so in benchmark, we have just, how do we define it? One query? We have multiple query definitions, right? Yeah. Oh gosh, let me just look at it here. So run benchmark. We connect and whatnot, and then we do for each iteration, we run each queries where each returns a list of things. Okay. Yeah. So the thing is that the moment we get empty list of times, we should just stop this particular thing and move on to the next iteration. So if times the length is 0, okay, we're just gonna do the whole thing, will be to do add empty results for the iteration and continue. Okay. If the query failed, we need to start over. Which is kind of in a way that the whole benchmark could fail because, I don't know. We'll see how many errors we're gonna get because something tells me with SurrealKV we'll be actually getting errors because with large data we already had that instance where we needed to switch to RocksDB because we just couldn't complete those. Okay, so but we're gonna get there. Okay, so we've got this iteration, blah blah blah. We could probably actually make it that each iteration runs in its own database, while each benchmark is its own namespace or something. Could happen, right? Because we don't want one benchmark to build upon the other one. All right, so we got the run query and whatnot. So I have the number of iterations count, its number, queries per iteration doesn't matter because we don't know ahead of time. So we basically want to have iteration results, and it will be iteration result, right? And that's it. Iteration result will be time per query. Yeah, and we'll just have a list of those queries, and that's it. Even though we have them separate, we're just gonna have one long string. That should be good enough. Okay, well, yeah, let's do that. So all those times. So for iteration, we're basically per iteration, we're to let iteration result. It's just that equals new. How the hell to create one? I didn't export it. Iteration result. How did I forget to create what? Iteration result is I can't create that because cannot find this. Did you mean that? Okay, it doesn't mind that now. What the heck? I'm using too many languages at the same time. I'm getting confused. How do I create a new instance of this object? Oh, because this is not a type. This is no, it's type. Of the iteration result type. Yes, and it should figure it out. Seriously? I need to do it that way because it's not a class, right? Okay, sure. Let's do it caveman way. Okay, so if we have that, we're gonna just add empty results. So iteration results. I mean, we're not adding anything, so we can just wait, because we're doing that. For each query, we're just gonna add that, right? So skip to like finish the iteration. So we're just gonna do break actually. Okay, because if we we run the thing at the times. If the query fails, we're doing that, right? Otherwise, we push the times to the query. And times is a list of strings. Time per query. And we just copy them here, right? What the heck? What is your problem? Argument expression expected. Is outside of the parameter string. That's why I want 3 dots. Oh, I typed in 2 dots, sorry. Great. So that's going well. And this will basically finish this. So if we finish that one, we can simply add it to our benchmark results. So let benchmark results is this. There we go. There we go. We just need to import that as well. And when we finish iteration, we just do benchmark results dot this push that. There we go. That's just that. Kind of ugly, but should make a little bit of sense. So running iteration that, and here we finish it. Great. Yeah. So that should run through all the iterations. And after all those iterations, we can basically do return benchmark results. And that should fulfill this promise. There we go. Okay. Okay, this is taking shape. So if that's the case, I need to just grab a bunch of benchmarks and run them, right? So let's define some basic benchmark. Okay. So this and that and that. So what we're gonna do here is for each databases, we're gonna run the benchmark. So run each query, dump results into CSV file, and close the connection. Yeah, that's another thing. So benchmark runner, it creates the connection here. And at the end, it's supposed to simply surreal.close or something like that. Or what do we call it? Database. Sure. There we go. Good. And closes awaitable? Yes. Okay. So if that's the case, yeah. So the thing is, do we want to run all the benchmark for one of the database and then connect to the next one, or do we want to run the same benchmark over multiple databases first and then continue? I'd say let's. Yeah, that's a good question. Huh. Let's do it in a way that we run all the benchmark per database, because this way we'll be able to theoretically run all the benchmarks for each database separately. If at some point we'll decide, you know what, let's deploy 5 different devices in the cloud and run all the benchmarks on each, you'll be able to do that from one computer. Okay. So for each of the databases, then we'll do basically 4 benchmark of benchmarks. Results is a way to benchmark, and then it will be results. Oh, we're not printing those results. That will be enough. So it'll be finished benchmark and name, right? So we're gonna have starting the benchmark and number of iterations. No, because we give it. What? I have iterations here? No, that will be inside the benchmark. And iterations. Sorry, not here. And now this is complaining, so this will be the benchmark.iterations. And I don't know why it's getting keys, but I'll let it for now. AI is doing its own thing. Okay, good. So now we're done. Provided here is all already defined in a benchmark. So now we have to basically start defining benchmarks. So let's just create a new file, benchmarks.ts. Benchmarks.ts. And I'm just gonna create the same benchmark that we were running so far, right? Not a big deal. So let's create a new folder. Benchmarks. Sure. And I'm just gonna create a new benchmark. Let's do it. First one for now. I'll just gonna call it first one because whatever. So if we have this first benchmark, how would we define it? Import, we need the query definition and benchmark definition, right? So export constant, first one, benchmark definition. There we go. Namespace, we're gonna call first one. Okay, there we go. We're just gonna even do without underscores, database. So that's the thing. Do we want database per iteration? I would probably do database per iteration. So let's do first. Jeez Louise. Let's remove the database part and in benchmark, because inside here, this is where we try to connect, right? Benchmark T, wait, where's our definition of a benchmark? Let's get rid of the database here. And instead of getting the database from the benchmark, huh. Because now the thing is that when we run the benchmark, we first connected the database and then run everything. So the thing is that we need to jump around and switch stuff around. So let's make creation of connecting to the database as part of actually running the query set. So per iteration, we're gonna disconnect and reconnect to the database. This way we will probably revert some transactions that went on or something. I don't know. So this will be create new connection and we do it here. So database, connect, and namespace and database will be basically iteration, and we have a number, right? That's gonna be our database. Straight up like that, so we'll be just spammed with databases. And do we have a way to actually delete a database in SurrealDB? That's a good point. I haven't seen anything about deleting a database. Ooh, this is gonna be spicy. Just a whole thing wrecked with thousands of namespaces and databases per namespace. Ooh, this is gonna be fun. Okay, great. The rest is fine. Okay. All right. And therefore we do that. And instead of database close here, when we finish the iteration, we push the results. And we close the database before we even push the results, right? Wait, it will be here. There we go. We'll see how that goes. Yeah. I'm just gonna add that little thingy here wherever we connected, just so that at least we know that we connected. Okay, great. Okay, so first one, namespace will be first one, queries, and name, well, basic query. Okay. Or this will be define table. Okay. So that will be the first one. Then we're gonna have another thing which will be test perform tests. That'll be our second query, and then we're gonna have another one where we want to basically run something like that's it. Okay. And the last one will be clean. Name is cleanup. Delete test one. Okay, because that will be our table. So we can mark it as SurrealQL, right? And we just need to do it this way, I believe, for it to be recognized or something. That doesn't work. Doesn't highlight it now for some reason. Oh well, this is good enough. Great. So this will be our query. So let's grab our code that we had defined here somewhere. There we go. This is our test. So we'll have it here. SurrealQL. And in theory, that will be it. But the thing is that I think we need the triple quote thing or something. What the heck is going on? Left-hand side of... Okay, triple quote don't exist. And how the hell do they do it in the other project? Oh, with backtick, really? Okay, well, let's do it with backtick. Sure. And I formatted in this way. Sure. Sure. There you go. Be happy. And we don't do the delete thing here, okay? We just have this like that, and we call it a day. So this will be our test here, and then the table definition, we're gonna do that. We're gonna define the table. So it's gonna be define table test one. Type normal. Oh, we can't use type normal because that won't be compatible with 1.x. Okay, so we'll just define the table, and that's pretty much it. Okay. Just so that we have something. And then we can delete test one and remove table test one. There we go. Iterations, I want 25 iterations per database. Ooh, this is gonna be long. And number of connections 1 because it's not being used right now anyway. So sure. Let's see if that's gonna work. Benchmark definition. Oh, yeah, I see. Type benchmark definition. There we go. Okay, all right. This is looking good. So in benchmarks, we're just gonna do export benchmarks list. Okay. And it'll be first one, which is import from there. There we go. There we go. Okay, this is good. This should be good. So here we can basically benchmarks list. Okay. And suddenly benchmark name doesn't exist. What? Oh, I really don't have a name for a benchmark? Name. String. So that this thing can be name. First benchmark for testing benchmarking. Okay. Great. So we've got starting and finished, and that's it. We don't do that. So for each of those databases, we go for each benchmark. So after we finished it, we need to basically dump the data somehow. But we're gonna ignore it for now, okay? So we're gonna straight up do something in our first one. We're just gonna say iterations will be 2, so that we can complete the whole thing in some specific time. This way, maybe I'm just gonna console I'm just gonna console print the results, and I want to see it run. Will it run? Bond start. Oh, wait, it was just doing things. What the heck? What the hell was happening? Starting benchmark for testing benchmarking. Okay, connected to RocksDB. 2 iterations, right? And these are results. We've got the numbers. Oh, right. Okay. Then a second. That was fast. Then we're connected to RocksDB RAM. That's good. Then to memory. That's good. And then we're going to Surreal 2 RocksDB. That was a problem. Problem of authentication. Really. Huh? Okay, so that's a new one. Why do we have a problem with authentication as a root user? Um, Sign in, right? Namespace, database, username, password. Let's just check the latest docs to see if there is something weird about it here. Get back home. Let's do JavaScript. Okay. So we do this, and that's our DB Surreal Connect. Okay. Oh, /RPC. We need to remember to add /RPC at the end. Okay, so that's the first thing, but I thought it was adding that automatically. And we use this, and there's no sign in here for some reason. So authentication, sign in. Username required for root. Password required for root. And everything else doesn't matter. Sign in, and wait, what? What's up with this thing? Do you have example? Namespace, username, password. How am I connecting here? Yeah. Namespace, database, username. Oh, I see. We are actually not supposed to put in namespace and database when we're signing it as root user. because that will make the 2.0 upset. But will that make the 1 point something upset? That's a good question. And let's just add slash RPC at the end, okay? Well, let's try to run it again. Okay, that went through, Third one, and okay, fourth one's going, RocksDB. Okay. SurrealKV is chugging slowly, holy macaroni. Oh yeah, now we're waiting 20 plus seconds for it to finish something. Mm-hmm. Okay. Come on, you can do it. SurrealKV RAM now. Okay, I'll be right back. Just short bathroom break. Alrighty, I'm back. So okay, and the last one finished quickly. I see. So all right, we have success. We completely went through all of them. So maybe I'm gonna start pushing some of that code because I don't want to lose anything. Oh, we got even good ignore file. Benchmark TS, benchmark runner, first benchmark, sure, database, index, package JSON, queries, sure for now. And query one, CSV. I'm not gonna push it yet because we can just redo it automatically now, which is kind of awesome. And readme, sure. Docker compose from translucent node now, and this. So this will be v1, like initial benchmarking automation. Okay. So the thing is that we just need to be able to save it to files now, so that we actually don't lose the data, because this is kind of not that readable, to be honest. So it'll be nice to just have it nicely saved. So in our case, how are we doing it in that case then? Let me think. So the spot to save data is we finish the iteration. Wait, inside the index. There we go. We finish the benchmark and we print out the results here. So we should do write results to a CSV file, and then to do calculate averages and standard deviations, and then write results to a CSV file. Okay, which will be raw results plus comma combined results. So, okay. Save raw data to a CSV file. Then we're gonna do, calculate totals, averages, and standard deviations. So, calculated results to a JSON file or something. Sure. So we need to do that. So now, how the hell do we do that? Because there are several ways to do that. I mean, we have such simple format that we don't need to worry about any kind of about any kind of, what would you call it? We don't need something that will, be a library for a CSV or whatnot. We just need to be able to save data, right? So let's do it this way. We're gonna go to fun file operations docs file IO. There we go. Reading files. No, I want writing files. Bun write. Bun write destination data. The bun write function is a multi-tool. Do we have an examples? Write a string to disk. There we go. We have data and bun write output. There we go. That's gonna be somewhat simple, I think. Do we need to import anything? The IDE will let us know. Then copy a file, write byte array, all that fancy stuff. Is there like an append or something? Incremental writing with file sync. Provide native incremental file writing API called file sync to retrieve file sync instance from bun file. So file is this, writer is that, and then incremental write. Write this, write that. Okay, that's what we're gonna use, because this is gonna be a little easier than keeping track and adding to a string or something, at least in my opinion. Okay, so a lot of emails. Okay, so I'm gonna copy this part and we're gonna create a new directory, results. Okay, so here we're just gonna make constant output directory is output. Okay, just like that. And then we're gonna basically calculate const current date. So there we go. Already knows that we want to do that. So I mean, let's just do that. Okay. Current data / class current data. There we go. So this would be our output directory. So output / current data, and inside of that we'll be creating our files. Hopefully, I hope it's gonna work. This way we can run it multiple times, and each time we're gonna get a new folder instead of things overwriting themselves and whatnot. So let's make some kind of simple new file, CSV writer .ts, and we're gonna make it real simple. Export function write to CSV, and data will be our benchmark timing results. Output directory will be a string, and there we go. That's all we need. So our output file will be very simple. Output directory plus the data, or results. It's called results, all right? Benchmark so that at least we have some kind of name for it. Result will be plus benchmark.name. Oh, then we need to correct names to something shorter. .csv. Okay, sure. That will be our file. We get the writer for it, and we just start going through the data, right? So the thing is, do we want to do anything with queries or not? Because because now the situation is that we normally you would have first row to be basically all the so I guess maybe we're just gonna get through the data a few times. It won't be as much data to really be problematic. That will be just a few kilobytes per result. So find the longest chain. Find the number of, not iteration, find the number of queries per iteration. Maximum number. This. And then we're gonna basically write the header and write the results row by row. There we go. So what are we going to do? Find the maximum number of queries per iteration. So we know that we're getting in results a list of iteration. Each iteration is basically a list of results of how long it took to run particular query. It's just a string right now. So what we can do is basically find the maximum number and that iteration, right? So let's do let max queries, okay, is 0. And then we go over all the iteration, and if the iteration time per query length, the list of that is larger than this, just upgrade it and that's it. So at the end we have the max number of queries, so we can actually generate the header. So we want to writer dot write, and we're just gonna have the first column will be iteration, and then we're gonna simply have the number of queries, right? So we're just gonna start, and then for all of those, starting from 1 to that max queries, we're gonna do query something. Sure, we're gonna add those, and at the end we're just gonna add the enter to go to the next one, right? And do we want commas? We can live with commas. Yeah, we can live with commas, so that should be fine. Okay, cool. And we start a new line. There we go. So we just wrote the header. Wow, this is really simple. And then basically for each iteration, we need to write the iteration number. And then for each other thing, we just write the time with a comma in front of it, without even the space. Okay. And new line at the end. And that is literally it. And we just finished the whole thing. Writer close. Do we have something like that? These chunks we buffer internally. To flush the buffer to disk, use flush. Okay. And to flush the buffer and close the file, we just did that. When the sync high water mark is reached, okay, sure. It's funny, we have a sync with high water mark, and you have flush. So everything related to water. I guess that's when you deal with streams, right? Everything's water. Okay, so we're going to do writer.end. There we go. What's going on here? Iteration. Result iterations, iteration results. So let's maybe do it different. For let I mean we do const I, right? Const I equals C1 I equals then results dot iteration results length. There we go. And then we're gonna do this whole thing. So instead of iteration, it will be the I. Okay, and this isn't happy because it needs to be string. So we just do this ugly thing. Sure. Can even put a number in front of it to know that it's actually that. And then we're gonna go results this thing I -1. And there we go. Okay, this looks better. So this should write the whole thing to the file. And that should be it. We'll see if we got it right the first time. So, how did I call it? Write to CSV. Write to CSV. Okay. And that's gonna be just just close all those unnecessary things. That's just gonna be the benchmark, results, and output. There we go. So we have the benchmark, the results that we just got, and the output directory. There we go. Beautiful. So before we do the other stuff, let's just run it. The only thing I'm gonna do for now is go to our databases and just skip the SurrealKV because they're just so slow. I just want to run those and see if we actually get files. And already we've got a first problem. Inside which file? Here. Oh, but there we go. So that's how it works. I see. And what do we have here? File writer. No such file or directory. Ooh. So how do we create a file then? How do we do that? Directories, files. Create a file. Writing file. Do we have creating file? Where are we? Reading, writing, directories, benchmarks. We have creating directories and all that stuff, and writing files. So something tells me the whole file thing, bun file, that probably has something with that allows us to create the file. So let's see. We have the file dot create apply color last modified. Comma. Have options. Blob property. Blob powered by fastest system calls available for size type. Okay. So let's try to file.write. Wait, how do we write to a file? Because maybe just writing will override it or something. Write function is multi-tool. Write, and we just do that. Wait a moment. What? How do I file? bound right. Oh, output and input file. Okay, I see. Bound right. And we do create. No, right. And this will be the file, comma. What options do we have here? We have this one where it takes the file, then it takes input, which could be a string, and then a bunch of options. So we want input options. I see. So the input here will be just this. And then create path. Ah. Mode number, create path. Create path, true. Let's try that. And then we should get a writer and keep writing to it. Let's see if that's gonna fix our problem. No, it did not. No such file directory. Great. What the heck? Hello? In our results, we have nothing. So maybe we just need to create the directory first. Reading directories. So reading directories. To read a directory in bound, use read directory from node fs. Ew. Creating directories too. Oh, and we don't have a nice check directory or something. That kind of sucks. So we're at least gonna do that. So when we start the thing, we're just gonna do this thing. Oh, and it uses await. Do we have top level await already? Or is JavaScript still waiting for that? Make directory from... Oops, I just added declaration. There we go. Grab it. Let's paste it somewhere here. Okay. And this will be our output directory. Recursive true, sure, good enough. Let's see if that's gonna magically save our thing, but I don't think so. Oh, it worked! Yes! Let's just see if we're gonna get the proper thing, right? Okay, so we go to results. Oh, output we got instead of results. Oops. Sure, output. We got the date for today and first benchmark for testing. There we go. We got our hello and EON. Oh, what? Oh, the writer start from 0. Okay, good enough. So what we're gonna do is we're gonna try to remove some of the bad code. Something tells me we absolutely don't need this line anymore because it was all about the other thing. So let's run it again. The only thing is that in that first one, I'm gonna make it run 5 times because I want some data. And I want to add one more thing. Basically, when we run our benchmarks and we run the query, currently times is just strings, right? I want it to be number. And therefore, when there's error, I'm gonna push -1. While otherwise, I want to kind of react to how we did things, because notice that it adds microseconds, milliseconds, and even if it's seconds or something, it probably does whole seconds or something. Oh, we got the benchmark. Oh, we need to, because it recreates the file for every something. Ooh. Yeah. Yeah. Okay, so we also need to make separate files per, what do you call it, for each database. That's another problem that we have. But here I would just like to strip all the milliseconds or whatnot and just express everything in milliseconds. So something like microseconds, it's just gonna be, we're gonna move the comma. So let's do that. What do we want to do? Maybe we want to do microseconds everything. I mean, it doesn't matter really from the float perspective. So let's do milliseconds, right? So we're gonna just run a very simple thing in our benchmark runner. We're just gonna add a function, 2 milliseconds time as string, and we're gonna return a number. Okay, if file, so the time string ends with milliseconds. We move it and return as a number. Okay. So if time ends with milliseconds, parse float, bam. Else time ends with, and we can copy the microseconds. Where is it? With microseconds. Wait, why do I have parentheses here? What? I need parentheses. Else if. Okay. Divided by 1000. There we go. Else if. We're going wrong direction. So let's start with microseconds, then milliseconds, else if, seconds, and else throw new error, valid time format. Can't convert to milliseconds. There we go, because I didn't think we're gonna get any other result other than seconds. There we go. So this will be 2 milliseconds. So we're gonna result time. So 2 milliseconds, and we just do that. There we go. So now we should get actual proper stuff. So the only problem is that now, where is it? Over here. On return times, it's just unhappy because it expects strings. There will be list of numbers. Okay. And therefore, now we're gonna add get some problems here because time per query. So let's redefine it as number. There we go. So this is a little bit happier now, but that means our other places will be very, very unhappy. CSS writer should be already unhappy. Or, oh, it's not. Because we're doing that. So let's just do it this more modern way. Okay. There we go. We're good here. And we have some problems here. No. Really? No other problems. Okay. I don't mind that. So now we just need to also change the file. Because we do per database and we write to CSV, we've got other than benchmark, we want to also provide the DB, okay? Or like db.name, name of the database. So write to a CSV, database name, string. So we're gonna do benchmark name. Plus dash plus database.name. Okay. So can I just convert it to interpolation, whatever, template string? There we go. Oh, that's so much better. Now it's actually comprehensible. So our first one, let's just rename it to something less spacious. First one. There we go. Just that. Underscore, so that we have weird stuff, and there we go. Okay, so I can get rid of, let's leave it. Let's run it now. Did I fix anything here? Where's our first one? We have defined that it's gonna run 5 iterations. Okay, so this will be nearly an equivalent of all that we did so far, only skipping the SurrealQL. Now when we go to output, we have already a new thing. Where we got the first one and the second file, right? We got this one, we just got another result and another result. Beautiful. Okay, that's what I'm talking about. Got Surreal 2. Ugly ending of numbers, but it doesn't matter. Spreadsheets will take care of it, right? Cool. And that's it. The temper query actually shows numbers now. Got from green or something to yellow. Yep. Okay, so we can see that also that first query is 003. Ooh. 00 something. So we're gonna go to the fastest one, which is the Surreal 1 in memory. We're gonna see that these are tiny numbers because 41 microseconds. Okay, I am very, very, very happy with this result. Yeah. So now let's just do this little summary thing, where I want to basically get a summary of it. Totals, averages, and whatnot. Don't know about total, but yeah, we could do total. So we have write to CSV. We'll be able to use it again, but I want to process results. Okay, so it will be the benchmark. Do we need the benchmark? No, we don't. The only thing that we need is results. And this will be let processed results. And then we're just gonna write the CSV. Okay. And we from benchmark, we're only getting the name, right? Just the name. So let's do benchmark name as string. This way, this doesn't need to have a reference to actual benchmark or anything. There we go. Better. That means that suddenly we can just do benchmark.name here. Well, this will be benchmark.name plus summary. Okay, just something ending with that, and there we go. And DB name, and instead of providing results, will be processed results. There we go. So let's process the results. So let's again new file, and this will be results processor. And we're gonna have export function process results. We get the benchmark name? No. We just need the results. Which benchmark timing results, and we just convert them to a new one. And that's it. So let's do that. So the whole idea here is that we take the iterations and we just define them a little bit differently. Yeah. For now, we're just gonna average them out and do something else, okay? So let's do it that way. We're going to do iteration 1, which will be calculate average time of each query. Then we have iteration 2, calculate total time of each query. Not really. Calculate, what is it? Standard deviation. Calculate median of each query. I don't know if that's gonna be possible. I don't know how it works actually. And then the last one, we have all those. Input number of results per query. And that's it. It's just gonna be a few simple calculations. So first of all, we create that. Let's summary is the benchmark time results, and it'll be just that. Okay. And what we're doing here, the first one, average time of each query. So we basically need to again calculate how many queries we have. So let max queries. Okay, I'm just gonna copy paste the code from here because we just need to know how many columns there are, and we'll need to also make sure that those columns also we take care of the -1 results or just not having that value there, because that can happen too if some errors will happen or something. So we've got that, the max queries. So not max queries. This will be queries count. Okay, there we go. So basically for each query count, yeah, the sum is 0, and what, for each iteration we just do that, add extract. But also if iteration time per query length is less than I, just continue. Oh, because we could just break it, right? For each iteration and that. No. Just break if we're out of those. Okay, other than that, just add it to the sum. And then we also need to count how many times we went through that. Instead of this, oops, what the hell? So this will be the query index. Okay. So for each query, we calculate the average. So for that query, we're going through all the things. So we actually don't want to do that. We just want to continue because that's just for a query. Okay. Great. and we do that. Wait. If iteration time per query length is less than the query index, okay, then continue. Other than that, sum is plus equals this and get the ID of the actual thing. But why are we going from 1, not from 0? What the heck? I guess because that's what happens. That's what happened somewhere else. Less or equal this. And yeah, we can have it this way. Great. So we basically go over all those and each iteration results. Oh, so let's do let entries count. Okay. Also, let const entry is this thing, right? If entry is -1, also continue, because that means we didn't get any valid entry. And then we just add it and do entries count plus plus. There we go. And at the end, we want to const average is this. I mean, if entries count as 0, just break, because that means we don't have more data. Okay. Because if all the iterations have 0 for that query, that means no further queries run at all. Okay, so const average sum. This is the average, and we basically do because that's the specific iteration, right? Because we have benchmark this. Let's make it let. Averages. There we go. Is just that. There we go. So we're gonna do this and averages push and bam. So after we finish that, summary, iteration, this, something of that sort. It's ugly as heck, but we have our thing. So now we just need to go standard deviation, which I am not sure how to implement, but I know that we don't need that right now. To do. Okay, and to do. And then number of core results. So we are actually going to save it at the end here. Let query results per query. It's just a list of numbers. Okay, that's all it's gonna be. So basically, we go over each query. We count the entries count. Okay. Yep. We push that and results per query push entries count. There we go. Beautiful. So at the end of everything, we just do summary iteration result push this and return the summary. So we're just gonna have a very tiny one for now, but that should work. And we'll import the process results. And we don't even need to give it a pinch mark, just go with that. There we go. So I'm gonna run the tests one more time, and I think I will be satisfied with the results. At least I'm hoping for that. And we can always load up those CSVs and do other stuff. Well, we did that, and there we go. Go through iterations, while in our output, we have the newest one, which is this one. And we first want summary. Well, here are the non-summaries. Okay. I could probably put summary at the end there, but oh well. Finished. So if we're in memory, we have results like this for each query. For summary here, we can see averages, how much for everything went, and we got 5 results for each query. Perfect. So that's the thing. So now the idea is to add more benchmarks so that we can compare them. Okay. What if I'm gonna grab this and actually paste it somewhere in here? Will that actually detect? No, of course not. This was split text to columns. Ah, look at that. We can just copy paste it and we already have results. Beautiful. This is gonna speed things up, that's for sure. So let me just get rid of all those, delete, and also the output directory because I want results directory. There we go. So that's gonna work well. I am satisfied. Now, benchmarks. So first of all, I would like the first one to have a variant of this one, but with actual indexes for all the numbers, so that in theory it should go a little bit faster, right? So let's copy this one and new file, first one with index.ts. So first one with index, okay? So we're define table test1, but then we also need to define fields. So define field. Oh, so maybe we're gonna define another one, which is like more schema-less. The other one will be schema full, and the next one will be schema full with an index. Okay, so number A on. I need to just do it this way, right? Define field number 8 on test 1. It was on or on table. I'm starting to lose how it was supposed to be. So let's open our learning Surreal where we'll have just a bunch of definitions, like a post. Define field, this on table, something. Okay. On table, test 1. And we basically say type number. Okay. There we go. And that's it, right? That's how we define the thingy. Okay, so we're gonna basically have a copy of that twice, number A, B, and C. There we go. So let's not code index yet. Or let's do that. So with index, we'll also have the how on earth did we define indexes? This on table that, columns that. There we go. And unique or something. We don't need the unique. So define index. Index number 8 on table test 1 columns number 8. And we don't need any unique at that. So that's first index, second, and third. B and C. There we go. And perform tests. We do exactly same tests as before, and we clean up exactly the same as before. The only thing is that instead of 10,000 records, I want million records. Okay, I want a whole million records because that's the real test of like, okay, I've got million records and I want to do stuff with it. So it's gonna run a little bit slower, but hopefully it's gonna be fine. And I'm going to copy this whole thing too. So first one underscore schema less. That's what we're gonna call it. Then we're gonna have first one schema full.ts. We're gonna rename this one to schema less. Okay. No. So schema full will be again, copy this one. First one schema full. So this way, what we're doing here now is that we're gonna run it without the indexes. There we go. Okay. And they'll be all running in separate namespaces, so in theory they shouldn't be affecting each other too much. Hopefully. I hope. And that should be it. All right. So we got 3 tests suddenly. And I want also the schema less to run with million records. 1, 2, 3, 1, 2, 3. There we go. And this way we should have, some kind of idea. And those values, there will be only 2,000 values that differ in each, so indexes should help greatly, in my opinion. There we go. So now we just need to go to our benchmark here because we have our, not benchmark Z somewhere. We close those guys. This thing. We want the benchmarks so that we have how we have them defined. Schema less, first one. So we also export them, right? First one, schema full. All right. Then we have first one, schema less. And first one with index. Okay. I mean, in theory, they could reuse the stuff. I have it copy pasted right now, but it's a start. Schema less. And then we've got import schema full and with index. Okay, and I want to run them in that particular order, and that's what's supposed to happen. The other thing is, how many times am I running those benchmarks? That's another question. So each of those benchmarks has a defined inside, right? So I want to run each one 15 times because this is gonna give us some more real life results if we run the same thing 15 times rather than just 5. And unfortunately, for that now, I actually need to go to database and unlock those 2. Although I'm gonna lock the RAM versions of both databases because I found them kind of sketchy and not really providing any information. So yeah, we don't need those RAM versions. We have 1, 2, 3, 4, 5 variants anyway. That's good enough to test things, right? Okay, and we have a comment from Misha de Vries. When you create a million records, do you return all of them to the client too? Otherwise, you should probably talk into account seaward decoding the client too. Oh, that's true. Thank you for for pointing that out, that we shouldn't really returning all the creating of meta records because database will probably try to push that. Thank you so much for pointing that out. I guess I would really learn hard way. So the thing is, when we create, I believe we can specify that we don't want anything returned, which will be preferable. So let's take a peek quickly. Where were we? Somewhere here. Statements, create, and we have return values. Okay, so we can just say none because that would be perfect. And Misha DeVries says, or do you go off of the time that the server reports it took to execute? I'm going off the time that the server reports that it took to execute, for now at least. I would actually like in the future to make it so that I'm logging both the time that the server reported it's going to take, and on top of that, the time that I actually measured. But then it will be actually difficult because, okay, what is the network here? What is this and that? So we'll see. We'll see. Another option will be to tap into when it's responding, when it starts streaming the response. But that will be very low level. That's probably what I will be able to do with nim, where I'm writing the thing to add some kind of hooks that, hey, we started getting response to this thing and whatnot. And the JS SDK exposes the emitter too. You could check when the response comes back based on the emitter, because seaboard decoding only happens after that. Okay, I see. So yeah, but is that emitter starting to execute? Because the thing is that with WebSockets, we're getting packets, small packets of data, I believe, not just one gigantic packet of data, right? And Misha says, I want to create a WASM Seaboard plugin. Do the course for the plugin speed up decoding and encoding Seaboard a bit. Okay, that sounds good. Yeah, I'll be trying to recreate Seaboard in NIM, so that's gonna be actually fun. Looking forward to it. We'll probably work on it a little bit on Friday. Okay, you get one response for per query execute. By response, do you mean WebSocket message? Just a single one? Huh. That's interesting. Yeah, that's gonna be fun. That'll be my first try at some kind of serious protocol recreation or something. So we'll see how that goes, but I would like to implement Seaboard because for sure there's a chance that, less JSON and string conversions, that's better, right? Okay, so let's add the return none to all those little thingies here. Okay, so let me actually recombine those because this kind of drives me insane. First one. Okay, I'm just gonna rename that, and we're gonna have it done in this way, where we take the first one, schemaless, benchmark definition, all this stuff, and we've got the queries, define table, this and that. And then this one is really a separate thing. So I should be able to extract it. Const, this will be the perform tests query, which should be the query definition or something. Query definition. And we just plop it here. All right. And that actually uses the type query definition. There we go. Okay, and we do that. All right. So we've got this one. So we should, in theory, just do perform test query. It's just is unhappy right now because this is kind of weird here. Because we have it as a constant. There we go. And the other thing will be cleanup. Cleanup query. Okay. So export const cleanup query. Misha says, yeah, and per group of queries that you send, by the way. Okay, just to clear. Good to know. With the seaboard, did you implement the seaboard on JavaScript side? Because if yes, I'm impressed by the TypeScript skills. I already have on my list that I need to properly learn TypeScript. Because conditional types confuse me at some point. All right, so now we have a little bit shorter definition here. That means that I can bring those over. There we go. And we're gonna have all of them in just one file. We've got this part and this part here will be copy paste from here. There we go. And one of index. And we've got that little part. Okay, this should be, whoa, what did I just copy? Wrong thing. Okay, there we go. So this should define them in one place. We're using stuff. So now I can do this thing. Return null. Okay, now we have a chance to actually survive the thing. And Misha says yes. So Misha is the one that implemented the seaboard protocol or whatever, encoding and decoding for the JavaScript library for SurrealDB. That's awesome. And yes, I am using 1.0.0 stable release of the library. I think I am. It's in the it's suggesting that this is the stable. It's 1.0.0 and no betas or anything else. Okay, so we've got the first one. Let's just fix that and we'll have from the first one schemaless personal schemaful and with index, and there we go. Ooh, moment of truth. I'm gonna try to run it. It's gonna probably take 30 hours. Yep, that's the one. Okay, so I know that the first, because we have our databases specified here. So RocksDB will be fast, memory will be fast, RocksDB fast, SurrealKV will probably be, we are running 15 queries. So it's gonna be 15 times around 30 seconds. So, okay, so that will probably run like 12 minutes or something. I'm gonna run it at the end so that we can start looking at the results after, those run. While the other one is running for a few minutes. Because I know that the SurrealKV, first, it's kind of slow, but it's in beta right now. But the other thing is that delete operation takes, at least to delete 10,000 records, it took on average 28 seconds. So yeah, I don't know what the hell's gonna happen here. We'll see, right? Let's start and let's see what's gonna happen with million records. Query define table. Okay. Now we're waiting for the create 1 million records. That's gonna be a fun number. Because previously it was what? Around 300 milliseconds, 200 something. No, it's gonna be a little bit more. A lot more. On the other screen, I'm gonna see if my NAS, the server that's running all that, is freaking out or something. Oh, it's slow. Actually, it's slow. My NAS is having trouble. Seriously. To create a million records, that's it. Each with random 3 elements. That shouldn't take that long. Define table. Perform tests. Okay. Did we lose something? What the heck? Oh, this shows in seconds. Okay. 46 seconds. I see. And then it took 27 seconds to clean up. Okay, CPU is only at 46%. That's not bad. Okay. And for storage, I don't have diagrams of if there's some problems. So interesting. So it's gonna just take a long time. Oh no, that was just iteration number 1. Oh no, I think we need to abort creating 1 million records. Yeah. I'm gonna stop it. Because this is gonna take 30 years. Okay, let's decrease the scope. One day I can just simply this stuff. And we have, unfortunately, bots trying to push something. Yeah, let me ban those things. How do I ban them? There's I can't click the ban button. Yeah, exactly. I got a stream to do. I think I'm gonna just do something like 30,000. This should give a meaningful number. Because even 70 seconds for creation times 15 is gonna be a little bit too much. Ban, wait, /ban, play lang stream. Go. And /ban. There we go. Okay, so here, test, let's do 30,000. And that's it. Should be enough. Because remember, we just started the thing. That we're gonna go over this thing again with schema full and then with indexes, which I'm really excited to learn how that's gonna affect things. Okay, we're going to 3 seconds or something. I'll need to fix that printing in the meantime. So as it's running, we can go to our benchmark runner because we have our run query, console error, query fail. Okay, took, and we have time. So let's just do as let time number 2 milliseconds, right? So we can just do this thing, time number, and we can push it here. And that's gonna be better for the next time. It's gonna clean up those little records here. We can see that this took just 1 second. Oh, okay. So, huh. 5 seconds. Wow, this is increasing so fast. Wait, what? So here it took like that, and then suddenly querying took 5 and 4 seconds. And we're down to 130, just something milliseconds. And it just went through like fast. What the heck? Now it's going fast out of nowhere. Okay. So we've got our first results, right? Results for the first one, schemaless summary. So we got 15 results. To create, this was fast. Then point. Okay, so this was create a table. This is define. Huh? Oh, no. It's just define table, yeah. And then hello, and then we've got the on average 1.3 seconds to create that many records. Okay, sure. And then we've got averages here. It'll be interesting when we'll be able to compare them. And we're already at Surreal 1 RocksDB. Wait, what do we do first then? Surreal 1 RocksDB. And now again RocksDB? What the hell's going on? Oh, we're going to second test. First one of index now. Oh, so we're going over test, third test already. So we got schema full and schema less. So schema full on average to create was, wait, roughly the same. 1310. 1310 nearly. Yep. Okay. So roughly the same thing. But then we've got the actual indexes and queries. I don't know, probably take the same time. We'll see. We'll see. I'll be able to plot it at some point. All right, and we're now in memory, which is going way faster. Look at that. Look at it go. And memory is creating those tables in milliseconds rather than seconds. Huh. Big speed up. And we're already in schemaless done for in memory. This is the schema full. And now we'll go with the index. Which seems a little bit slower, but that's because we create a big index and then use it literally once or twice or something. So that's the thing. If we would be reusing it a lot, that would be a difference. But this should give us enough of like measurable data to get something out of that. And then we're going over SurrealDB 2. So this will be probably a little bit slower. But I'm curious because now we increased the size of data a little bit. Maybe that's gonna change something. But at the same time, I'm really afraid of SurrealKV. How the deletion will be happening. Okay, we're going over schema full now. Oh, it's 2:16 already. Holy moly. When this is finishing, we're gonna just briefly go through the results. And probably tomorrow I'm gonna start writing some kind of summary that shows a little bit more of the data so that I can share it. Okay. Bam. And now the one index query failed. Query failed. Indexes already exist. What the heck? Something is going on here. Why is it something like that? I deleted the table and each one is running in a separate namespace. So what the heck? Misha is asking, can I ask what NAS do you have? And is the sort HDD or SSD? So the NAS is QNAP. I don't remember the name now. It has in the README. I have some notes. So it's AMD Ryzen embedded V1500B. It's not a fast processor. It's not a fast one, but I can run some virtual machines, some few things. I have some RAM. It's DDR4. I believe I had 32 gigabytes, so has plenty enough of RAM. And then it has 8 HDDs as a ZFS file system, but they're assisted with SSD read and write cache. So, yeah, something like that. Am I even running any virtual machines on it? I think I'm running, yeah, Nomad server right now, but it's not doing much right now, so it's very low. Because with all this CPU utilization right now, it's 25%. Okay, so RAM utilization is 35%. I'm going to go to container station and see the containers. Do I get any? I don't get any data here about that. Yeah. This doesn't have any fun visualizations. But I can see that logical cores, whatever, the usage of CPU for Docker is 31%. Memory usage that's assigned for Docker is 36%. So, you know, it's not upset right now. I was planning to run all the queries also on my PC. So, you know, on Homelander, on Translucent, and on my laptop, but I'm just encountering some problems with Portainer because, you know, I have just a single YAML file that runs 8 different deployments of SurrealDB with, depending if it's RocksDB. I even made things where it runs something, for example, on RocksDB, but the file system is the Docker in-memory file system as a variant. But I just need to figure out how to properly deploy that on other devices because I'm getting some storage problems where I can't start SurrealDB, to my surprise. Okay, we got the schema less on SurrealKV. It's gonna be a little bit slower, and deletion, I'm afraid it's gonna probably take a minute per test, so hopefully not a minute. Hopefully. Because that means it'll be half an hour here with waiting for it to finish. Misha says, I'm not well known with ZFS pools and stuff, but it might not be optimized for small writes and maybe reads. Just guessing, though. Yeah, that's why it has the SSD cache to just take care of those quick things that eventually it will be written to drive. to thing is like, has 500 gigabytes write and read, little SSD based thing. And the thing is, I'm also comparing the memory based stuff here. So it's not that drastic difference so far, at least with those simple queries. And like I mentioned, I want to run a few other devices that are a little bit more modern, a little, bigger processor or whatever, and faster RAM, faster everything. Because I think that NAS is the slowest device, or maybe the mini PC is the slowest. I don't know yet. And the other thing is, I'm running all 8 instances of SurrealDB at the same time next to each other as one Docker Compose deployment, but I'm using only one at a time. And right now we're still waiting for SurrealKV to delete the 30,000 records, which Sunny tells me it will take 1 minute and 30 seconds. Although it feels like it's already longer. So I might probably just start dumping some of the data into the spreadsheet. Okay. Where did my spreadsheet go? There it is. Sorry about the bright light, but that's how spreadsheets work. So we're gonna call it the first test results. Okay. And we're gonna go with schema full, schema less, and other stuff. Schema less. And let's try to get our data. It's still trying to delete those records. Oh my goodness. Yeah, SurrealKV has some problems with deleting records. Okay, Surreal 1, RocksDB summary. Gosh, they're ordered totally wrong way. RocksDB summary. So I'm gonna grab this, copy, and we'll do v1.515. And this will be the RocksDB. Okay, I'm gonna paste it here as columns. There we go. Okay, I'm gonna make them a little bit larger for now. The other thing is that I also want to kind of make all the values as we've got microseconds here. Yeah, 1 microsecond will be good enough. Okay, there we go. Still on the first iteration. Oh, it finished after 266 seconds. So it's like 4 minutes, nearly 4.5 minutes to delete 30,000 records. So it grows exponentially. Okay, I see. Yeah. Huh. Very curious. Okay, so that's gonna run through the rest of the night probably. So I got this. Then we have Surreal 1 memory, right? Mm-hmm. Oh wait, that's schema folder I'm looking. I want schema less summary. RocksDB 1. This is the value I needed. So this goes away. Bam. And we copy this as in memory. Okay. So 1 in memory. Copy this data here. Oh, it's 2 columns. Oh no, I did do that here. Do I have? Nope. Come on, cooperate. Okay, there we go. Now be v2.0.1 RocksDB. And that will be the schema-less RocksDB. Okay. Then we're gonna do the in-memory. I mean, SurrealKV. We're not doing that right now because we can't. We're still waiting for results. This will be the in-memory. So for in-memory for 2.0, it's this thingy. Copy, paste it, and bam. All right, so this suddenly shows us roughly what's going on. Okay, so let me just write down the steps of the first one, the schema less. Still waiting for the second iteration. Holy macaroni. Wait, this is schema full, this is schema less. So we have just first is just define table. I wonder if I can straight up mark those as. Is there a shortcut for merging the cells? I guess not. Can I select them all and merge vertically? Ah, there we go. And can I make text to run like this on a diagonal? So I can just kind of enlarge this one. So this will be define table. Okay, that's this step, define table. Can I also make them like this and like that? There we go. Beautiful. How fancy. The next step is just return hello. Okay. Then we have create 30. Okay. And then we have the other stuff. So what's the other stuff? So we create 30K and select all. Select all 30. Or we'll just select 30K. Okay. Then we've got the, yeah, I should improve that by not counting also the, because one thing is to return them, the other is to just query them. Okay, so the third one will be basically find matches. Find matches. And then will be find matches partial. Can I control enter? Only return partial. There we go. Oh, fancy. I like this diagonal thing. And then we have the cleanup, which will be delete 30K records, and then will be remove table. Okay. So these are our findings so far for schema-less. Okay. Define table. It looks like there's no significant difference. This is probably within error. Return hello. for some reason on RocksDB is 162 microseconds. So a fun fact, even though this is like return hello, something that doesn't touch any data, and it's just, you know, it shouldn't touch any data, because just, hey, return me that string back. In memory, it runs really, really, really fast. But when we have RocksDB, it doesn't run really, really fast. It runs, you know, 5 times slower. Here, nearly 10 times on older one. Very, very interesting. Then creation of records in memory, the old version is way faster than in memory current version, while RocksDB 2.0 is a little bit faster than older RocksDB. Interesting. Okay, and again, that's just for 15 samples, so it's not the biggest. I could run something more fun at some point, but I'll probably run something that runs for maybe overnight or something when I will actually, you know, make it run on other devices. Selecting 30K. This means that it also returns all the data. All the 30,000 records are being returned as a, you know, text as a response with like everything. So, you know, something that would be returned here. So that means that old RocksDB versus new RocksDB, we have significant speed update. So that's nice. It wasn't showing that too much when with 10,000 records. And then we've got in memory. Older in memory again is way faster than the new in memory. So that's interesting. So in memory, running memory just was faster in 1.5. But at the same time, it had probably older one had less rules and less features. Find matches. Again, it returns lots of data. And now the new version is significantly faster. Okay. Nearly twice as fast. Or like exactly twice as fast. Oh, that's nice. Find matches and return only partial strings. Basically the same thing. It doesn't really seem to be bothered by the fact that it needs to serialize way more data here rather than here. So that's interesting. And then deletion is actually way faster now than it was before. Because deletion in 1.5 with RocksDB took 2.7 seconds on average. Here is now in 2.0 is only 827 milliseconds. So what, nearly 3 times faster? That's pretty good. Or like over 3 times faster. Great. And removing table, okay, that improved. 17 milliseconds versus 153. And again, in memory is just, bam, remove that chunk of memory. It doesn't exist anymore. It's really nice. And SurrealKV is probably like, you know, 5 minutes. Which is kind of nuts. Okay, this is some result. So that was schemaless. Okay, let's now go over schema full. Okay, and we can just copy this part so that we don't have to write that anymore, and then we'll be with index. So that means we'll be just moving some stuff around. And here we got already to the 4th iteration. Oh dear. Huh. So it takes a while to remove. Yeah, over 5 minutes now. And it's gonna keep increasing. Okay, so let's go to schema full. Surreal 1 RocksDB. Okay. Then we go Surreal 1 in memory. There we go. RocksDB for the 2. And then we've got Surreal 2 in memory. It'll be somewhere here. Because I don't expect SurrealKV to finish it until probably tomorrow. Okay, so we have just a few steps added here. I'm gonna delete all the old stuff because it kind of didn't really work much. So that means that we'll need to add a few columns, because what the difference is with the schema full is that suddenly, instead of just define table test1 and that's it, we are doing define table, and then we have field A, B, and C. So what we need to do is insert column on the left, and on the left. All right, just like that. So now I can actually grab all those, place them here, make sure that they display the same number of zeros as well. And this will be here. Again, add them vertically. And oops, like this, like that. And I think they already have, yeah. So this will be define number A, define number B, and define number C. Okay, that's all it is. And they all roughly define things the same way. Okay, although the first one is taking longer. The first time defining takes longer than the next times. Okay. And for definitions, there's not a lot of overhead in adding a definition versus in memory versus not in memory. So that's very interesting. Those things run nearly as fast as in memory. So, and we can see that this all took a little bit longer. Not really. This actually got way faster here than was here. So that definitely clearly shows that we need to run it way more than 15 times. And returning hello is exactly the same. Fast, super fast in memory, weirdly slow here. And again, there's less of discrepancy here. And here suddenly we have that it takes longer to create overall in memory and not in memory. Because I guess if we have schema full, we need to verify that the data is correct. And it looks like verification is a little bit slower, possibly on RocksDB. But again, this is just 15 samples. So I'll definitely need to run it many more times. And then we've got select, which was roughly, it's weird, like here those run so slowly, here they run faster than in the 2.0. Here they run nearly as fast as in memory. What the hell? And here is also the same, nearly as the same as in memory. In memory actually took a little bit slower. That's interesting. Okay, this is unexpected. What the hell happened here? Why is selecting and finding matches and returning partials so much faster when we have defined a table? I mean, faster. Here, marginally faster, but for the actual, what do you call them? For the actual file system backed, they got really fast. Like, you know, from 500 to that much. Here from, I mean, here is roughly the same. Okay, so for 2.0 is roughly the same. Interesting. So I don't know what the hell happened here. The same for deletion. Here suddenly 2.0 is slower than 1.0. Both in memory and not in memory. Interesting. While removing table is, again, super fast. Oh, look at that. So remove table here takes 25 milliseconds compared to random stuff here. Okay, so yeah, we need way larger sample size and start a standard deviation to start making sense of that. Because we don't know what's the fluctuation between, you know, which data is good, which data is bad, where we can expect stable things, where we can expect less stable behavior. Okay, so let's just add the index, which will be 3 more indexes added, and see how long that took. Okay. So we have the, gosh, this is just on the 5th iteration. The previous one took 6 minutes to oh dear God. Not sure if I can complete those right now. So let's do it this way. We go with index summary for Surreal 1.x RocksDB. Bam. Then we've got memory for 1.0 or 1.x. Then we've got 2.0 RocksDB. Oh, and that's where we're getting the query errors. It didn't complete. That's true. And I have no idea why, because it was saying that, sorry, the index already exists. And the same thing for this one. What? What the heck just happened here? Because it went over indexes and it just didn't even continue. So we've got query defined table. Like, you know, for serial 2 in memory. Define table, all 3 fields, and we have, oh, sorry, index number A already exists. And then it performed tests but didn't write them down. Okay. Oh, because of stuff. But how on earth does index number A already exist? Unless namespacing for them changed or something? Because that's, how about iteration 0? So we've got this thing and iteration 0. Already in the first iteration, it was already complaining that index number A already exists. Oh, did I make a oopsie? I probably made an oopsie. I am probably defined 3 indexes with the same thing. Like a moron. Yep. So our index stuff is not worth the effort. So let's rerun just the last test. We'll just do B and C. Okay, I'll save it. I canceled it. The connection dropped, so I hope the database soon enough will figure out that there's no point running it anymore. Yeah. I'm not gonna run the KV, SurrealKV, because it just doesn't work. I would need to skip the deletions somehow, because other than that, it's just strange. So we're gonna run it on those 4 databases for now. And we're gonna, in our benchmarks, we're just gonna run only the one of index. So we're just gonna do this. Wait, I could just do this, right? Just put them on separate lines. There we go. Just this one test. Database and whatnot. We have those. You go away. And what do I want? Just double check that our indexes are actually correct. A, B, C this time. There we go. So look at that. Now that we would need the override keyword, we actually know that we had an error. We thought that we didn't have an error. Interesting. I'm gonna run 30 iterations per each. This is where we're gonna just have a little bit more accurate data. Okay, so let's run it again, and we're just gonna run only that first one of index and nothing else. Yeah. So these can go away, and we have a new one here. Yeah, this is definitely a project for a few live streams, so I'm gonna enjoy that. Alrighty, so did we get anything yet? Why is it so slow this time? 4.5 seconds to clean up? What? Oh, because we're doing the indexes or something? Oh, that means during deletion, it probably just straight up needs to keep maintaining the indexes as we're deleting data. Oh, that's something I didn't think about. So it will be beneficial to just straight up first remove the indexes, delete data, and whatnot. I mean, here at least, to speed it up. But this is not very realistic, so yeah, at least we're benchmarking a little bit of indexes. Okay, we're halfway through the first set of iterations, so that's not bad. And we can see that initially, the data that we started gathering initially, where is it? Here. I mean, I just need to add 3 columns here. 1, 2, 3, and name them appropriately. So this one will be index number A, index number B, and index number C. So now I can just move the data and it will all align. Okay. And of course, we need to make them a little bit more readable. Okay, so for deletion, here in memory and somewhere else, it was relatively fast because we had only one index to update. And now it's way slower because we're probably updating 3 indexes every time we delete a record. Interesting. So Misha says the thing with delete is that you also need to fetch schema, check for running events, and indeed update indexes. I believe if you delete a table without removing data first, it's much faster. Yep, but that's not what we're after, of course. Yeah, that's not what I'm after. And I want to... The thing is that with this tool, I will be able to test those two. And what is the actual difference for the variety of sizes of the database, for example. I would also like it to be able to, let's say, bootstrap a database per test or something, using Docker, so that I could actually, have it run fresh database every time. Because the thing is that if I'm repeating the same test, it takes longer and longer and longer because the records are already somewhere, some hashes or whatever indexes in the storage layer, and it just drastically slows things down. We have first results for the Surreal 1 RocksDB. Okay, so we can update our data. Copy, and we're gonna paste it here as this thing. There we go. Brand new complete data. Okay, and this time I'm gonna add 15x because those 15 shots and whatever samples, and this will be 30 samples. Okay, so we've got a value here, and we can see that on average it's 4.8 seconds. Wow. All right, but did anything speed up? What the hell happened here? Why is it suddenly so much slower at everything? Not at this thing. Hello, it actually sped up out of nowhere. Creation slowed down drastically with indexes. Selection roughly the same. So no difference here, just deletion slowed down. So that's interesting how that goes. Like how much varies, like suddenly all unrelated things like before the index suddenly increase. Raphael Darley says you get things like tombstones and compaction, which will slow things down, at least in the short term. Though it would also be interesting to look at how performance characteristics change in use. Yeah, that'll be fun. I can imagine having, a bunch of really small tests that, let's say are run on a fresh database, and then maybe something that is designed to run, maybe generate a whole long sequence of some kind of actions that simulates how data would, how this whole data will be being submitted and, processed and whatnot in a little bit more chaotic way. But even though it's chaotic, it could be that, using some kind of random and seed to have it generate the same thing every time, and therefore eventually, be reproducible, because sometimes just writing a schema is just a little bit too much. So that's an interesting option. And we got the in-memory results, which are a little bit faster, I think. And at the same time, I want to be able to run it on multiple machines, including something like GitHub Actions, where we could actually try things out a little bit more. Although with GitHub Actions, I think there's very little when it comes to predictability of how fast things go. Okay, so we've got in memory. Yeah, this is across the board way faster than this for some reason. I don't know why this got so slow. Well, here was comparable. Truly random. Not sure. At some point when the connection is established, it goes slower. Sometimes it goes faster. And not sure where that variance comes from. Well, this is suddenly faster than any other one. And we've got that. Well, here it was way faster. Here, actual deletion is faster than creation, huh? In memory. Well, it's opposite one with a stored system. But querying itself is surprisingly fast across the board. Like there's not much variation if we have indexes or not, so interesting. And now we're going over the RocksDB on 2.0, so we'll see how that goes with 30 shots and with indexes. If, I know, maybe suddenly some optimizations, I don't know. Come on, you can do it. Yeah, the worst part about it is just takes time. And Raphael says, I would guess it's because RocksDB creates tombstones instead of actually removing data. This will happen over time, but just after a delete, there seems to be performance degradation. Yeah. Yep. It probably just does that to quickly mark it as a tombstone with possibility that can be unmarked. I don't know. I have absolutely no clue. And are there any plans with something like SurrealKV to, for example, be able to disable, for example, record versions or some other things to gain performance? Because that will be another interesting things to be able to configure it that way. As in, you can tune your database a little bit more to what you want, and maybe have even some kind of different sets of maybe environment variables that, you know, like presets. Okay, I want fast performance, but maybe with this or that or that. And that could be an interesting approach to just have few presets for the database that you can start from when tweaking. Interesting. Okay, so we got RocksDB for Surreal 2. Alrighty. So we're gonna plop it here. And this time it passed. This time the whole thing passed. And we have massively large numbers for some reason. What the hell happened? Like, it's a... What? Why would defining... I mean, that's just milliseconds, so... But why did it take here this much and this much here? Something's going on with my NAS, probably. Yeah, the CPU went all the way up for some reason. So I am not sure what the hell's going on. Did we just finish maybe in memory or something? Um, No, in memory it's still going. So that might be slightly unreliable data. Like very slightly, as in very largely. Oh no. At least we have a framework to start testing, right? Because besides those just being, you know, milliseconds, you know, doesn't matter. What matters is those numbers, which here are, again, slower than 1.0 for some reason. Significantly. From 3.8 seconds to 4.4 seconds. Yeah, but it's constantly slower than 2.0 for some reason. That is unexpected. I thought 2.0 will be like significantly faster in most cases, so I'm not sure what it's optimized for. Where's this thing here? Okay, just finished in memory. And we're just gonna wait. This is the 2 in memory. There we go. Okay, so we're gonna paste it here. and just format it a little bit. Okay, so here we are back to fast. Index is fast. Everything fast. And this is, again, slower than 1.0. Interesting. Across the board. Huh. I did not expect that 2.1 will be actually slower. Were there any instances where it was faster? With those weird setups where suddenly it took longer here than in other areas. So there are some moments where some of them, especially 1.5, like I think it fluctuates way more than some other areas. So that's very interesting. I think that could be something worth investigating. So I guess I'm gonna share that on the SurrealDB Discord because this is kind of fun as initial results. And I'll be able to do a little bit more of that later. Wait, what did I delete? Okay, so okay, first source results, and we've got that, and yeah, that's that. Now, how do I share it nicely? So, because I would like to maybe, can I export as PDF or something? As PDF. Okay, this is workable. Sure. Yep. No. There we go. A little bit nicer. Paper size. Whatever. Okay. So I'm gonna export it as that PDF. And I'm gonna share it on Discord. You know. But the thing is that I also need to gonna push it into the repo as well. So let me just grab that file quickly. And we're gonna put it into new folder, docs. Okay. First stream results. Okay, I'm just gonna put it like that, and I'm gonna move things like query 1 CSV. We don't need that. Result processor config readme queries.markdown. We have all the queries in there, so no worries. License, database, and everything else is just a normal stuff. And translucent, I'm gonna delete that because it's just not really necessary. So going back to the code, this can go away. I'm gonna go here. Let's just complete the README, and we'll be able to kind of start doing things. Target deployment during live streams. And that's the goal. Okay, Docker Compose. That's that for now, so I'm gonna leave that as well. So a set of simple benchmarks of various aspects. Stream number 1 results. Initial results come only from a single machine. Java. And were performed only with the following SurrealDB versions. 1.4 with default storage engine with the in memory. Bam. Okay. The SurrealKV was not tested yet due to slow deletion performance. I'll just put in beta just so that if somebody goes through that, they know that SurrealKV is still in beta. Okay. The results are available as a PDF file here. Okay, so we're just gonna do that, and this will be, what is the directory? docs/first stream results. There we go. And that should be good enough for now. Those results were, keep in mind that the results are only from a single machine and from 15 to 30 iterations that introduce, that don't filter out any outliers, or I don't have the statistics person lingo. So I don't know how to write it. But roughly something like that. Yeah, I'll just keep it in there so there's some kind of context. And we'll continue on this particular project next Wednesday. I mean, week from now. Yeah, this is gonna be fun. So let's just push those changes because there were a lot, I guess. So yeah, benchmarks, and first one, CSS writer, the results, right? Okay, the readme updated. I am not pushing anything inside the results because these are just raw results, although I could kind of include them, right? Because that's kind of the goal. So I'm gonna put that in there. For now, this is something that over time will be replaced. Okay, and from here we'll have the schema full. Okay. And schema less. And index, those were the invalid ones, so I'm going to discard them. Okay, so finish stream 1. I know that most of the stuff is hard-coded in there for now, but as we process the whole thing, it's gonna be a little bit nicer, I hope. Okay, so let's push it. And that concludes the stream today. All right. So I thank everyone for watching. I hope you find it somewhat useful. It will be a little bit more useful next time, especially as we will be able to start getting some more meaningful data. Probably run it over time, and you know, over the days I will be probably sharing a little bit. And yeah, that's it. So if you enjoyed the content, consider liking and subscribing on YouTube or following me on Twitch. And you can also join my Discord. Link is in the description or right somewhere under here. Raphael says thank you. Thank you for participating and, you know, sharing some insight. I know that I'm not a you know, benchmark person here. It's just for fun. But hey, it's fun to start learning and seeing actual numbers. It's a bit different than when you're thinking over the database and everything feels so snappy. So yeah, see you everyone. Possibly on Friday, I will be making SurrealDB driver for NIM. So we'll probably start attempting to implement the Seaboard protocol, because that seems like something that will open a little bit more type, would open doors for more static typing when it comes to queries and stuff and results, and it'll be like nice to have that done before we start implementing, more of the library. All right, so thank you again, and see everyone later.